Hello, welcome to Room 101. This room is sponsored by SpiderBat. SpiderBat's platform for cloud-native runtime security shows you exactly what is happening and secures your Linux VMs and Kubernetes clusters throughout your software development lifecycle. Visit SpiderBat's booth to see it in action.
Thank you. I'm Don Thomas. I run the security track here. I especially invited Christian, and Zeek here to give a presentation. I think their product is awesome. It's directly one of the best security open source projects out there, and there's a commercial version of it, but the open source is fantastic. So with any ado, I'll hand it over to Christian and let him show the product.
All right. Thank you, Don. I hope this is working. It sounds pretty good. Let me know if anything. Yep. Okay. Wait from the back. This room is great. This is a little bit like an airplane. It's like super narrow and super deep. The emergency exits and all that. So thank you, Don, for the invitation. Very much appreciated. I have, I guess, an hour to talk about the Zeek project. Let's get this going. So I wanted to take a quick moment to just ask the room how many of you use Zeek? How many know Zeek? Right. Cool. Just a handful. Okay. That means there's a very small segment that might use it. Okay, cool. One. All right. Great. Okay, this is good because I was going to sort of be quite basic and spend about half of this on Zeek. pairs, and you get this little bit of output there. So it'll write out to the console, right, establish connections from, and then it goes over that set and prints out the IP addresses. And I'm going to show you what this looks like. I mean, you can probably imagine. So a typical like small scale sort of Zeek invocation would be just like Zeek-R to run a PCAP, and assume that I took this previous script and put it in awesome.zeek command line and run it, and then this is a small PCAP, right? I actually have a laptop, and so you got these two IP addresses. The next thing that Zeek is also a log writer, and this is probably the most important sort of aspect of the system for most people, because you are very unlikely to use Zeek without actually consuming logs that the system generates. And this is actually sort of a handy overview. I think I didn't put this together, somebody else did, that sort of conveys a little bit what this looks like. So you have sort of a structure where you can sort of cross-link, pivot, sort of across different logs in the system. And there are logs basically for protocols, for particular sort of notices, for sort of themes and things you sort of care about. There's sort of a sneak preview sort of there in the bottom right. And so the way that works is basically the script interpreter can say, okay, write a log entry of a particular log out to however Zeek has been configured to do that. And so that usually goes back into the core, and here again we have pluggability. So depending on where you want your log entries to go, you can basically configure the system to write out to that sort of log ingestion technology. The default is just to write logs to disk, but there are many others, like Kafka is a common one, and when you get and the important bit is that you get that functionality by default. So even though I wrote this little Zeek script here that was digging into the originators of the connections in this PCAP, what I actually get if I look at what's now in my directory is a bunch of logs. That's basically because the DPI engine and the analyzers have dug into the flows and basically sucked out what was the HTTP specific traffic, what was SMB and so forth, which files were in that PCAP, and basically just dumped it all out into logs. And this is getting very small. I hope I warned the folks in the back, but here you go. Just to convey sort of a little bit what that looks like. So the con log is sort of our hub for logging. It's basically sort of the thing that connects to essentially almost every other log to give you sort of the central state for every connection that Zeek sees. And I'm showing you that output here in JSON, and that's basically one default way that the SCaLE logger can write out as. And this might be a little bit reminiscent of NetFlow, if you've seen that in the past. But you can, if you have, also already tell that this is richer. So you have things in there like the connection state entry, which basically sort of tells you what happened over the lifetime of that connection. And then there's the connection history, for example, that is sort of near the bottom there, that is really cool, that basically sort of is a very short sort of slug that summarizes what happened over the lifetime of a TCP connection. And so since I've sort of been in this for a while, I can tell you that, okay, so there was a SYN here, there was a SYNAC coming back, the handshake completed, there was data exchanged in either direction. We use uppercase for one direction, lowercase for the other, and the A's are pure X. And just from that little string alone, for example, you can often identify tapping problems, like when something isn't quite right, when you only see one direction of a flow or so, you get entries there that tell you right away, like, oh, this is suspicious. And near the top there, you have this sort of string, the UID, and that is basically how we tie logs together. So if you also looked at, an HTTP log, for example, for this connection, if it were one, or in this case, SMB, then you would see that via the UID, you have a means to cross-link those entries. Okay, so that sits on top, back to this. And so the next important thing I want to flag is basically sort of a architectural, sort of philosophical sort of aspect of the system. And it is that everything in lighter blue here is mechanism. So this is just implemented in Zeek to do one thing. Like in the log engine, a plugin just writes out a log entry. There is no sort of, complicated algorithm to that. You can basically just implement that and you're done. Or an analyzer can just sort of parse into a protocol and that's sort of a predefined task. Where the script layer shines is policy. Like basically whatever you load into that interpreter defines what Zeek does. And this is exactly the reason that sometimes makes it a little hard to explain what Zeek really is, because the answer is, it depends. The default that we give you is a lot of logging, like on that previous slide, so you learn a lot about what's been going on in your network. But you can do other things like detections and so forth. So that sort of guides a lot of like how we implement things in the system. Is it policy or is it mechanism? And we want to keep things that should be left to the user completely possible to enable to implement for the user, while only providing the machinery that you need to actually do that. Sort of important, and I think it's a differentiator from other network monitors. So, for example, thinking of signature-based intrusion detection systems, they built this a little differently, right? There is an assumption that what you plug into that system is a detection. That is not the case here. So it's in a way a lot more flexible. Anyway, so what we have now is a Zeek process. So I have built this up sort of bottom up, and everything you see on the left here is running in one Zeek process. And so why am I pointing this out? Well, earlier I said Zeek is a distributed event-based system, and if you look at this and you know it was a process, then you might go like, why distributed, right? That is not a distributed system, it's just an event-based system. Well, that's because usually in production, you don't run Zeek as one process. So you can probably imagine what's coming, but instead of one process, you run a bunch, a cluster. And so the way you go about this is you basically take a set of processes, like how many is usually defined by, you know, the magnitude of traffic that you want to parse, how beefy your machine is, how many cores it has, sort of all that kind of stuff. And so you assign roles to your cluster. These are sort of the predefined ones, although you could technically have others. So the common ones are a manager at the top that is essentially sort of the central coordinating unit, and often also the main node that keeps a lot of sort of centralized state. There are these things we call proxies underneath that have a somewhat sort of misleading name. They're basically just a load balancing mechanism, so that as you start to, in your script, sort of distribute state across the system, you don't put all eggs in one basket and put everything in the manager, but actually sort of spread that out a little bit. And then at the bottom there you have the workers, and they do what you would imagine. You basically sort of like, they get the packets out of your network tab. If you run this on a single machine, that's basically done by the NIC for you. If you run it across multiple machines, you need a network load balancer, something that distributes packets out. And that then goes up. And I just skipped the node on the top right. That's a logger. We usually dedicate separate processes just for the task of logging out, because those can easily be bottlenecks as well. And so it's nice to have that sort of separated out. And so what happens next then is that here comes the distributed aspect. The nodes speak to each other and do event pops up, publish, subscribe. So it's kind of hard to visualize this in a diagram, but basically picture that there are topics for every kind of node or other ones. It basically, again, just depends on what you put in the script layer. And then different nodes in your cluster can subscribe to those, and then whatever happens in your network is automatically communicated across this cluster, so you can react to it. And so this then is a Zeek cluster. So I just walked you sort of through the basic node types. I thought I'd flag that, you know, we built this stuff sort of in-house, except for the message passing library that underpins all of this, which is called CAF, which is the C++ actor framework that you might have heard of or not. I didn't say that all of the core is implemented in C++, and, you know, scripting layer is its own thing. So if you want to scale these things, your first go-to is usually to add more workers if you find that, you know, you can't keep up with the traffic, or you need a little bit more flexibility in where you place state in your system. And as your Zeek installation grows, you will often find that if it's a really big network, then you don't get a lot by with one machine. You need multiple machines, and then you can really start thinking about, well, which parts of my cluster do I want to put where? And you often have scenarios where you have multiple machines that are just running workers and that are basically funneling all the traffic analysis up to manager, proxy, and logging, and so forth. That whole aspect is pretty tricky to figure out. So I wasn't going to talk about this a lot in this presentation, because I think it could easily fill an hour just by itself. But to really get sort of to the bottom of packet capture and how to scale clusters, I I think it's a ton of fun, and it'll take you a little bit, and you will learn more about your network by doing that than but many other things that you can think of, because it's just, so essential to the whole thing. And it also, I should mention this too, means that our notion of a cluster is very different from how many other people think of, modern cluster topologies. So we're not talking auto-scaling across 1,000 nodes here or anything like that. This is basically defined by your hardware's capabilities and what you can do with network capture, because that will guide how many workers you bring up. If you don't have one of those workers running, it basically means you have a little blind spot there for the traffic that would have ended up in that worker. So it's a much more sort of rigid structure than you have in these sort of like highly dynamic sort of come and go style clusters, which has certain downsides because we have less reliability, if you will, but certain upsides too, because we can argue about that cluster in ways that are perhaps a little bit more nice than you have in very, very large and dynamic clusters. We can basically say like, this cluster is now up and running, right? We had a nice sort of philosophical debate in the team the other day whether that still makes sense for Zeek clusters, but we came out on like, yep, it pretty much does, which is nice. Okay. Now, so what is Zeek? So Zeek is a mature, extensible, distributed, event-based, scriptable network data logger. So that's a mouthful, and you will be forgiven if that is not impressing. It's basically too complicated, right? Like there's a much easier analogy for what Zeek does, and it is this. It's the network flight recorder. And those of you who are old, like me, might remember that this actually existed sort of in the early 2000s. There was an actual product. If Marcus Raynham were in the audience, he would chuckle right now. But this is basically like version 2 and then some of that, right? It's way more flexible, extensible, and so forth, everything that was on the previous slide. But if you want this one bit in your head for what Zeek gives you, then it's this, right? Because it allows you to record network data at scale for long amounts of time, and you can control the extent to which you log into the details of this. Okay, but Zeek is a lot more. So this was the main Zeek system. And we built a bunch of stuff sort of around this as well. And I wanted to just sort of walk you pretty quickly through this. So the first thing that you should know about is what we call ZeekAG, which is a package manager for Zeek. So this has existed for probably, I should know this better, but I think just under 10 years now. And before that, it was always tricky when somebody had written something meaningful in a Zeek script, like how do you distribute that? Because you had to sort of like put it up on the internet somewhere, point people at it, and they had to download it and put it in a folder somewhere. So the obvious solution to that is basically a package manager. So we built our own. This is sort of part of the outer ecosystem, which we often build in Python. So this is Python stuff as well. Jumping all the way to the bottom of the slide there, you can see you can just install it via pip, or depending on how you install Zeek, you get it sort of installed by default anyway. I'll talk about that later. But to just sort of convey the flavor, I think this thing is super cool because it basically lets you build packages for almost anything that you want to plug into or modify about Zeek. So it's pretty large. At the moment, we have just over 200 packages, 210. I think I did a quick grep again yesterday. And sort of I just sort of like scanned through sort of the types of packages that we have, and they're basically packet sources. Like, so, oh, I said package there. Packet sources, right? Like earlier with AF packet and so forth. So we've got the ecosystem there, I think, pretty covered. Then on the other end of the system, it's log writers. So like what you write logs to. Pretty nice setup there as well. If you're using sort of exotic log ingestion technologies, we would very much like to know about that, right? Because that's sort of like what we have to supply so you can like use the system to ingest data from us. There are lots of log extensions where you basically take the existing logs but tweak them, like you add something to it. Like there's one package where you get HTTP bodies, or one that includes VLAN tags, geotagging. There's one for this thing called community ID that is perhaps on your radar if you're in the space a little bit, and it takes sort of this notion of a connection identifier that I mentioned earlier, but up-levels it from Zeek to basically any system that taps, traffic and identifies connection, so you can connect and pivot across data sets across these technologies. This is all stuff that is pluggable and you can sort of add to your system. There are functional add-ons. I didn't really sort of cover that in the architecture, but the plug-in machinery in Zeek allows you to tap into more things than I showed in that diagram. So basically you can add implementations for pretty much anything in C++ and make that exposed in the script layer. Like if you wanted to what did I mention here? Yeah, storage I/O if you wanted to talk to Postgres, or testimony was super cool, which is this basically packet distribution mechanism. I think that was built by Google. ICAP, this sort of like built-in closed-loop solution for making decisions about whether a packet is benign or not, or a flow is benign or not, and so forth. So it's really pretty powerful stuff. Extensions for frameworks, so like basically shifting over from individual new things, but sort of the core functionalities of Zeek. You can add analyzers. We have had a lot of contributions around industrial control system traffic, which is awesome because you have to have a lot of domain expertise in these protocols, I think, to be able to write parsers for them. And then detections, and there are lots of those. I'll cover that a little bit later, but basically picture that you have a lot of freedom in how you express a detection. And if you've been in that space for a little bit, then you start thinking differently around how you build these things, sort of thinking more across flows, across hosts, and more about state and state machines, and at which point you have sort of flagged a detection. So you can shove all of that into packages. You can also start sort of from the other end if you just want to dabble in this a little bit. This is a package manager that also lets you create packages. It's templated. You know, no great magic there. You still have to do sort of the deep thinking to understand what you want to put in there, but you don't have to futz too much to get this going. Like the main layout and the metadata files and so forth, like that's all there for you. So that's a great one, I think, to be aware of. And then there's a whole bunch more. And this next one here, called Spicy, could totally be a talk for next time, maybe, Don. But this is sort of a sub-project that we've had for, also I think about a decade. And that is the brainchild of a good friend and colleague of mine, Robin Sommer. And this is basically our take at how network traffic parsing should really actually work. Because if you look at how most projects go about this today, the answer is that it is ad hoc. So every system that needs to parse TCP has its own TCP parser. Every system that needs to parse HTTP has its own HTTP parser. It doesn't scale, it's buggy. If you look at Wireshark's history, which is a project we are greatly impressed by, because they implement so much parsing code, of course, they've had a ton of vulnerabilities because you have, like, we're no different. Like us too, Suricata too, TCP-DOM too, you know, it's sort of, it's a common truth sort of in the industry that this isn't that great. And this is basically a parser generator that builds on experience that we've gained over the years with an early prototype that we've had in Zeek for a long time called BinPack. And so depending on how you feel about programming languages, you might chuckle now, but it basically compiles a DSL, a domain-specific language that expresses the syntax and the semantics of a protocol into C++. So if you're a safe language diehard, you might not find that very safe, but the win here is that it is predefined how that implementation happens, right? So like you can tweak a bug that might come up there in one place and all parsers written for this thing benefit. And it's designed to work on streamed data, which is really important because if you build a system that parses network traffic, then you never just get the whole thing. You get sort of, you know, the next chunk and the next chunk and the next chunk, which makes this really important and differentiates it from things like Yara, for example, where there's a built-in assumption that you have a file and then you can parse it. And the final point there is the one that excites me the most. This isn't designed for Zeek. We happen to start using it in Zeek, and we're really only starting to use it. It's been a long process. We're working with the Wireshark folks to get that in there. This is early prototyping on their end. But the vision for this is basically like, wouldn't it be cool if you could go to this repository and you had like pre-written parsers for lots of protocols, and you want to use this in your system, and you just grab that parser and you link it up in the code that comes out. Anyway, so this is, I think, among the most exciting things we're working on these days. Broker and CAF, so this is our middleware. I basically covered that in the cluster slide. It's kind of cool, it's kind of quirky. It is one of the things where, you know, we've invested a lot of time, and we sometimes wish, well, how should I put this? We were using something a little bit more mainstream because it is just so idiosyncratic to be using the a message broker that is built in-house based on an actor framework that I think not too many people know when there are lots of other go-to technologies out there. But it has worked extremely well for us. It's matured technology, and we're benefiting from a bunch of functionality that we're getting, particularly out of Ceph, that has really nice telemetry support, that also at the broker level implements some of our data store functionality and so forth. So this is really the key underpinning for everything that we're doing when you're running Zeek as a cluster. And speaking of cluster, again, at the bottom there, I'm mentioning something called Zeek Control or Zeek Cuddle. This is our original cluster manager. This is sort of also an interesting one. It's been around for a long time, and it basically is funny because it dates back to a time where if you wanted to run a Zeek cluster, it by definition meant that you were running multiple machines because a machine had one core. And so accordingly, that's sort of like how the thing was designed. Like this is very sort of SSH and rsync sort of heavy, because it actually sort of goes into machines and changes Zeek configurations and brings nodes back up and so forth. But it's, like I said, it's very mature, it's very flexible, it's very powerful, and it's the go-to way these days still where, you know, if you run a big Zeek cluster, this is the tool you manage your cluster with. There is a replacement in the pipeline called Zeek Client, because we're basically rethinking the way you should be able to interact with a Zeek cluster to basically bring that to the modern era a little bit. And so instead of thinking about like machines and like things you log into, we're building something that is a lot more service oriented, where basically since you have the ability to communicate in a Zeek cluster, we thought we could also build the cluster management itself in Zeek. So you can talk into this thing and say like bring up a node and so forth. And that has started to appear in the current line of Zeek releases, and it's another thing that is written in Python, and you can basically install it separately and start tinkering with it. And then we're going off sort of into sort of even more periphery, sort of. We've started to invest a little bit in developer tooling. This is sort of because, you know, we write a lot of Zeek script code, and if you do that, then you would like some convenience with that. And so we've built out, you know, sort of alternative parsing technology for Zeek scripts that lets us, you know, write indenters, linters, that kind of stuff. If you're into that aspect of languages, I think that's pretty cool. We have btest, which is an old tool, but you know still underpins all of our testing essentially, and it's I think useful to know about because it too is not about Zeek at all. It could be used with any project that basically needs sort of system level tests, where you say, you know, here's a test case, here's input to my test case, here's output, and I just want to understand if that output was correct. So like very useful for baseline testing. And it comes with a bunch of functionality that's really useful if you're into sort of test-driven development. Okay, two last ones, two websites. Try.zeek.org is especially awesome if you're sort of relatively new to Zeek, because it lets you go to a website and without installing Zeek or anything, sort of tinker a little bit with the scripting. So you could take the script that I showed earlier and basically paste it in there and run it. And you can even select at the bottom, like which Zeek version would you like to run that with, which PCAP would you like to run it on. You can't upload your own, but we provide a handful, that kind of stuff. It even comes with a little bit of training if you want to sort of like explore aspects of the language. So great stuff, hopefully around for a long time still. And the second one is packages.zeek.org, which is basically our online, you know, package browser for ZKG, for our package manager. And this thing is a little dated. There's actually an effort underway right now to revamp it, but it's the thing you can go to for searching the packet database a little bit. Like, is there something for the protocol I care about, or for the CVE I care about, and so forth. All right. And this is a biggie. So all of the stuff that I just covered is BSD licensed. This is something that is sort of in our lineage, in our sort of heritage. We just feel pretty strongly that this is the way we want things to be. And so it should enable you to use it in pretty much any setting you can think of, which is, I think, pretty great. So that sort of concludes the technical side of things. And I wanted to walk you through a couple of use cases that are common for this, because I think it sort of just conveys a little bit of what the system is about. So this part I've already touched earlier, but so the first, like the main bit that I would like you to keep in mind when you think about Zeek is just that it's better network data. So if you think of the big go-tos, right, you usually have, you know, PCAP, and if you put this on this like two-dimensional like continuum, right, so how accurate, what's the fidelity of the data sort of going to the right? Like how close is this to what actually happened on the network? PCAP would be all the way over there. It is literally what happened on the network because it's every packet, right? And on the data volume scale, it's also all the way on the top because it's everything that happened on the network, so it's really voluminous. On the other end, if you don't care at all about what happened on the network and you just want to know, was there something malicious, you have alerts, right? This is what every intrusion detection system in the last 20 years has been up to. And that's the exact opposite. So you know almost nothing about what happened on the network other than some system said it's bad. And there's almost no volume because if it's good alerts, you only get these sort of golden nuggets that you care about. Oftentimes, unfortunately, you have crappy alerts. so you're, you're in the same space in terms of data fidelity, but higher volume, not super high, but hopefully, right? But not great. And then you have things like NetFlow that are sort of somewhere down there because you learn more about what's going on the network because you get a per connection sort of summary, so you can say like, oh yeah, this guy has been talking to something strange. But not a whole lot beyond that. And as a plus, the data volume is hopefully also manageable because you're now abstracting all of the packets that make up a connection to just sort of a one-liner. And the point I want to convey is that Zeek is all over this, sort of because again, policy-driven, right? It depends on how you configure it, what you get out of it. So if you want mostly detections, for example, you can configure it such. You don't have to have all of the logs that I showed earlier. You can turn those off if they're of no value to you, then you would sort of land in the bottom left there. Or if you want very rich logging with file extraction, HTTP bodies, SMTP stuff, whatever you name it, sort of, then you would end sort of on the top right there of the blue sort of sphere, but it's not predefined. So if you ever come across sort of, marketing materials or anything that try to place Zeek in sort of one particular place, then you should pause and go like, well, it depends, right? Because it depends on how it's configured. All right, so that's the biggie. And then just to walk through some typical use cases. So by far the biggest that comes to mind is sort of for network detection and response for workflows, it's empowerment. Because if you build out a storage solution for these logs, then you have this incredibly rich information about what happened in your network, but at a volume that, depending on your infrastructure, allows you to go back days, weeks, months, and in some cases, years. Like we have a very good sort of working relationship with folks at Lawrence Berkeley Lab, and they literally have like decades of Zeek logs, and it is incredible. So for example, if you think back to Heartbleed, when that came out, obviously a huge deal, right? And there were all these questions about like, okay, so, well, was that exploited before the vulnerability was announced, right? And the folks at LBL basically like dug into their logs, and at least for them, the finding was like, nope. Like until that thing was, announced, we saw no exploitation of it because you could tell from the Zeek logs that weren't built for Heartbleed or anything, right? But they had rich enough logging that you could sort of grab that out of the data. For threat hunting, so for folks who basically want to sort of proactively look for things that have happened in their network, in their infrastructure, it's a goldmine for the exact same reason, basically. You don't just have NetFlow. You don't just have alerts. You have all this structure. So you can look at what are the hosts that have spoken the most in a protocol that I didn't expect to a country I don't want that to see happen, for example. Right? And what I particularly like in this is that because Zeek scripts basically codify analysis, you can sort of push this whole thing to the left. So you don't have to sort of like collect lots of crappy data and shove it into your data analysis solution. When you have hunches about how you will usually be doing your analysis, you can codify that in a Zeek script, deploy it, drastically reduce your data volume, but get sort of the entry points to your remaining analysis out of it, which I think is really great. There's data enrichment here is just another sort of example application, and we have a couple of sites that we're aware of that do this incredibly well, and they've basically built this sort of workflow, round-tripping workflow, where they use Zeek to learn about what's in their network infrastructure. Then they enrich the data with sort of context for what that means. And so the cliche ones would be like, this is the HR department, this is the engineering department, and so forth, and then sort of iterate. And it's a really good way to understand new machines coming on your network, phones, and so forth. And then finally, detections. So I tried to touch this earlier, but sort of basically think of the possibilities you have when you don't need to think about having a bit that you can set for a particular connection, but like arbitrary tables, state setting, state expiration, and so forth, and what kinds of detections that enables. And you can just go to that website and search for some CVEs, and I think it's, since the 2020s, it's been about 24, for example. So for many dominant modern exploitations, we find that we can pretty easily sort of, with very little scripting code, build good detectors for. So once you're in that space, it's sort of a little hard to sort of come back out of it because like, you're basically used to the flexibility that that enables. Okay, switching gears a little bit, like if I have convinced you that this is great, I wanted to tell you a little bit about like how we do releases so you would know what to install. And I'm sorry, I'm getting over a cold, which is my nose is so runny. So our release cadence is as follows. So we aim to do 3 releases per year, where the X.0 is our long-term support release. So the latest of that right now would be 5.0. And then as time goes by and we find, you know, bugs or security vulnerabilities, we do a lot of fuzzing, for example, to find these. We make point releases, right? So like after the X.0 and X.0.1 would come out, and in the meantime, development continues, and the next release that comes out is the .1, so a couple months later. And that is our, we remove deprecations release. So if you switch to that, you want to be extra careful because we might have changed something in sort of slightly bigger ways. And we have a file for that in our distribution that you can always check out. That is basically like a release log, but it will make sure to call out sort of things that you should be aware of. And so once that has come out, the same sort of style of development continues. We might do point releases if there are bug fixes and so forth, but we will also backport that to our long-term support release. So, like, you know, if there is a bug fix in that .1, then you will also get it in a bug fix release in the .0 line of releases. And so again, development continues, and the .2 comes out. So, for example, just a few days we released 5.2, and at that point, the .1 line of releases is essentially stale. Like, we will not backport fixes to it. So if a new sort of release comes out, that would be a .2.1 and an according backport to LTS, and then the cycle is complete. And we don't really guarantee 3 releases per year, but I think we're pretty good at sticking to that. And I'm going to take a quick moment to blow my nose. I apologize. Okay, so I think that's useful context because otherwise you would just sort of see release numbers and wouldn't really know what to get. So when in doubt, get an LTS release. If you have the freedom to sort of like grab something recent, make it the most recent. Not everybody does that. We in production, we see a huge spectrum of releases out there, but that's sort of our recommended approach. So here's where we are right now. So in the 5.0 sort of or in the 5, I should say, cycle of releases, we just started 5.2, and so that means 6.0 should come out sort of at some point in the mid to late summer. And you can go to our wiki down there if you want to read a little bit more about this. Ways to get Zeek. So if I have you interested now, you have a couple of options. So 3 in particular. So if you just want to tinker real quick and like run some Zeek stuff, maybe crank through a precap, or just sort of dig in a little more, you can grab our Docker images. It's just Docker pull Zeek. And you have a lot of tagging options there. You can grab a specific release. You can grab latest. You can grab the latest LTS release just via tagging. Or you can grab a nightly, which is pull Zeek/Zeek dev, which is basically if you want the latest and greatest but don't want to build it yourself. And just since 5.2, we started to do multi-platform builds, particularly for the folks running Macs. This is great because there is also now an image that is on ARM. Most convenient for folks who want to take it a little further is probably our binaries. And our setup there is sort of interesting, I think, in that we use SUSE's open build service to build the packages. Which is really handy because they basically give you, the repo infrastructure. They make it pretty easy to build for different distributions. And so we do that basically for the most popular Linux distros. And the way it works is then basically, as usual, you just have to do one extra step by basically adding their repo and then installing from there. And the thing to keep in mind is that this isn't as seamless as it would be if we would offer packages that are distro native, like if you were on Fedora and you would just say DNF install Zeek or something like that, basically because we lack cycles. So I'm pretty sad about this. The OBS setup is sort of the closest that we can come to this right now. But if there are packaging wizards in the room, I think the delta from the spec files and so forth that we have built for SUSE OBS to actually making it distro native is probably small enough that it's, for somebody who is well versed in this, I think probably pretty easy to get going. So that would, if you're curious and would like to get involved, that would be a terrific way to get that started. And then there are a couple other platforms where people that are not us, basically third-party, external community contributors, have built packages, and we're hugely grateful. This is Homebrew for the Mac, and then FreeBSD and OpenBSD in their ports and packages. FreeBSD, maybe a couple words on, used to be the go-to solution for running Zeek. And then Linux basically kept getting better at packet capture and so forth. So I think the defaults have switched. And OpenBSD, we personally have the least experience with, and are therefore also most eager to hear sort of feedback in case people are around who use it on that platform, because it's obviously great from a security perspective. And then finally, you can install it from source. And if you think like, oh dear God, like it's not actually that daunting. The only thing that's daunting is like checking out the code, because at this point Zeek is pretty complex. There are lots of submodules and stuff. It's very sort of Git oriented, but like basically you can just grab a tag in there and build it. And the build requirements are actually very straightforward. They're pretty much what you would expect, which is basically a compiler tool chain, Python, and you're sort of there. And maybe a cool thing to mention there is that if you're building from source and you are at home on Windows, which is probably sort of historically not the go-to for somebody doing network monitoring, that is starting to become feasible, because we had a really cool contribution from Microsoft, who started to use Zeek internally in their products, specifically Microsoft Defender, and we're willing to open source the stuff that they did there. So there was this mega PR that especially my colleague Tim worked on very closely with the Microsoft folks, and that is now in the release, in the 5.2 release. And maybe just to throw that out there real quick, so that's emerging, and if you're in that space, we would love your feedback, but it's not at all at the same level yet of running it on Linux or another popular Unix platform. All right, more details in our documentation down there. So that basically concludes all the technical stuff. We never talked about Q&A, but presumably toward the end is better. Yeah, okay. Now would be a good time. I think I have 5-10 minutes maybe still. Is that okay? Yeah? Okay, cool. That's perfect. So the Zeek project. So there's one thing in particular to start with that you need to know. So if you go into a checkout of the sources and you look at the tail end of a file called changes, you see this, and if you look a little closer, you see this, namely 1997. So I'm not here to tell you about anything new. This thing is old, and there's a good reason for that. It is basically because, where to start? So there is a mailing list that is called Bro for reasons I'm about to explain, that goes back all the way to 1998 to almost the beginning of this project, and it is a ton of fun to dig in there sort of in the early days and look at who showed up and what was discussed and so forth. And the reason I'm mentioning this here is, why is it called Bro? It's, well, because the thing used to be called Bro. And in fact, it was just last year that the creator of this system, who I obviously have to mention here, which is Vern Paxson, was awarded a Test of Time award. And if you know academia a little bit, then those things are a big deal. And it's just pretty funny that it was 2022 for a paper that, it's very tiny down there, but that was written in 1998, right? And at that time, the system was called Bro. And you can also see the security sort of perspective in there, because like in the title right there was detecting network intruders, right? And the reason we renamed the project, which was in 2018, I believe, was because in the modern era, Bro is a very loaded term in this community, and we felt that was no longer sustainable, so we changed it. I have overheard marketing conversations like you wouldn't believe. It's like, yeah, so we're commercializing this thing called Bro. It's like, no, really, it's called Bro, sort of like that. It's hilarious. So we had to change it, and so that has now happened. But you will find that some of the Zeek packages still have Bro in them and so forth. If you dig deep enough in our code, Bro is still mentioned in there and so forth. So that is why. Okay. Another thing that this conveys is because Vern back in the day did a bunch of cool stuff. If you don't know Vern, look him up sometime. He was on the early TCP congestion work, did SCTP, like lots of interesting stuff. But what I'm trying to convey here is that it meant that all of the early, for a definition of almost 20 years, early work on Zeek happened in an academic context, so basically research and research papers. And this slide I'm greatly indebted for to Robin, again, who put that together. And I just really like this because it conveys how much happened with the main focus being academia. And it sort of tail ends there to the right of the slide with Corelight, because the other thing that this conveys, which I will cover in a second, but the other thing that this conveys is that for the first almost 20 years of the project, the way the project was funded was academic funding, the National Science Foundation and so forth. And this is a total detail here, but the blue boxes on this slide basically convey funding that was mainly to do hacking, I'm just gonna call it that, to basically put this thing sort of like tech transfer, right, to put this out there. And the others were essentially like research, like how do you build a system that does X, Y, and Z. And the reason this matters is that it explains a little bit about our project philosophy, and especially the first point there. Because in academia, you don't get very far if you say like, well, what's the off-the-shelf thing we can use to solve problem X? You kind of go like, well, in an ideal world, like what's the best possible thing we can build for that? And we have tried to do this, and Spicy is a really good example for this. Like, this is just how we feel parser technology should work. We could have also gone out there and taken Rust, which is a completely reasonable solution in my opinion, but it is more interesting to build something that like really nails it. The problem with this is we've almost done this to a fault, because over the years, and now you can say decades, we've built a lot of things that we therefore also need to maintain. And that gets harder and harder because we're a finite team, but the code keeps growing. You could say, like, well, keep growing the team, but that's tricky. And so that's a really good one to keep in mind. We tend to build things so that they're the right thing, even if it takes us much longer. And from academia, we've also inherited the spirit a little bit that we'll release this thing when it's ready, you know, whatever is the new thing we're talking about. And I have to sort of caveat this because our release manager, Tim, gets grumpy if we push that too far. So this is Tim Wojtulewicz. He's our release engineer. And he would very much like us to stick to 3 releases a year. So Tim, whenever you see that, so I've made your point. And then the other 2 are pretty reflective, I think, of any open source project. Listen to the community, because they often have feature requirements that are really interesting that we didn't think of. And you might find it interesting to know that actually all of the core developers of Zeek aren't really Zeek users. This is a little strongly put, but most of us don't have a network that is where we have Zeek as a security critical application that we monitor 24 hours a day. We basically just built this. We have a lot of context. We talk to people a lot in that space, but we have to listen to the community, because otherwise we might just build the wrong thing. And therefore plans change every now and then. So sometimes we have sort of embarked on a project and then thought like, oh no, this is actually the wrong thing. Let's sort of like back up a little bit and build it differently. All right, so I thought that should be out there. Project structure, and now I'm getting into details. Couple of minutes perhaps. I would like you to know that there is a lot of thinking behind the scenes about how this project should operate. We have sort of a leadership team that guides the project. We have technical leadership. We have a greater project team, and we have various subgroups that focus on specific aspects of this. And just to like sort of mention the names of the people involved, like if you think of like the Zeek team, it's essentially these people. Most of them are very much involved. Others were particularly involved in the recent past and still sort of contribute as they can. And if you spread it out across the roles a little bit, it looks like this. And I'm mentioning this mainly because on the top right there, you see the core folks doing development work. So that includes me right now. And I technically hold the technical seat on the leadership team at the moment, which is why you saw that on the first slide, but that will rotate over the years. Before me, Robin Sommer held that role for many years. Vern holds our founder seat because he created the whole system, and we wouldn't be here without him. There's an election process for the leadership team every year, so if people are interested, you're all very welcome to apply and get elected and so forth. And a few words about the Zeek community. We have, I think, a pretty interesting structure in the team in that it is split across very different roles. So we obviously have security teams that use it to understand what's going on in the network, but we also have network operators, so people who don't necessarily have the security context and who really know their networks, but for example, oftentimes we find aren't really developers. So it is easier to get a security team to go like, okay, I'm gonna write a package now, than it would be for some network operators. Of course, it's blurry, right? It's not predefined, but that's sort of a split that we've noticed. And then the newest is perhaps sort of on the bottom right there, what I call observability engineers. I don't really know if that's a thing yet, but my hunch is that it soon will be. And these are basically people who sort of try to understand what is going on in their infrastructure. And the key bit there is infrastructure as opposed to network, because we're increasingly thinking of Zeek not so much as a network monitor, but an infrastructure monitor, because it's broadening to host-based stuff, so you can get events from your hosts and not just out of the network. And it basically makes for a much more complete story about what you understand about what's going on in your infrastructure. So that was basically it. You are all very welcome to get involved. I have sort of a long list here of ways in which you can get involved, but I will not read through this. There are 3 key bits in there. Like, tell us your use cases. Like, if you're using this or you're interested in using it and you find it does something well or not at all, just tell us. It would be really, really good to know. If you want to contribute, cool. We have external contributors all the time. It tends to work best. This is another open source truism. If you want to build something big, get in touch first. We can help you. We can provide a little bit of context. Like maybe there's an older pull request somewhere that you could base on and so forth. And if you're not a developer, not a problem at all. You don't have to write like C++ code. You don't have to write Zeek scripts. We need a bunch of other folks for helping out with testing, documentation, training is a big one right now, all that kind of stuff. That's it. That's all I had. Here are some links. You can find us on Slack. You can find us on Discourse. We'd love to see you there. So thank you very much. And are we doing Q&A or I can happy to answer anything. I'm also around for hours still. So yeah. Hi. Yeah. Yeah. To the left. Yeah. Yeah, it's not a, yeah. So it's essentially just sort of an idea. So picture, so if you engage in threat hunting, it's a data analysis task, right? Like you dig into like tables and so forth to find certain subsets of entries that you then sort of like build more analysis on. The idea there was that since you can codify what happens right in the network as you're watching packets, you don't have to potentially export a lot of data into your data ingestion solution that mostly will not be valuable, because you will filter it down anyway to something that is more actionable for you, that you then build further analysis on, because you can just write that in Zeek and build your own log for it, for example, or like filter the existing logs in a way to get rid of stuff that you don't care about. So that's what I meant by shifting left. If you picture the pipeline sort of where you start from packets and then you have Zeek and then you have logs and then you have data ingestion and then you do your analysis, you can basically do the meaningful stuff further on the left. Yeah. Yeah, go.
I like to run this at home lab. What do you recommend? I mean, I don't use this at work, but
Yeah.
home lab, do I just grab some CPAC files?
So home lab, is home lab a thing or do you mean your home?
I'm going to run it in my home.
Okay, cool.
I'm going to have it run on my reform CPAC.
Yeah, this is great. Yeah, that's a really good point. So the crux, this is a great topic, because we would actually very much like to be better at telling you things about your home network. The problem usually is that for most people, it is actually hard to tap their home network. So you basically have to go out of your way a little bit to do something. And we've all sort of dabbled in this. I don't think we have the one go-to. Like you can go all the way from like building, like having your own switch in there to something sort of like for really small networks. You can, OpenWRT is a contender, although I think you have to tinker a little bit to get a build in there. That'd be a good one for us to deploy out of the box. Don, you had a...
If you go to Black Hills Information Security, they actually did a small version of Zeek off of a Raspberry Pi, I think. Yeah, and they tied it in with a very small hub, something that you can actually buy through, one of the vendors like Newegg or something like that. And then you can do that in your home lab. But yeah, there are certain hubs that you can buy that will have a port that has a broadcast port. That'll take everything there.
Yeah.
Yeah.
But
Yeah.
so
Did go through their archives. They have a, I forgot what they called it, a Pi something, but it's a Zeek Pi. Look for
Okay.
Zeek Pi in Black Hills.
and even before that though, before you start tapping and stuff, if you have any way to get a PCAP, like or download some off the internet, literally, like to get started and get a flavor for the whole thing, that's the way to go, because the. Yeah, exactly. Just start with that, right? And then you understand what the data are. You can try everything. You can use the package manager. You can change functionality. You can do it all based on PCAPs. Like I didn't mean to suggest that you have to run a cluster. It's just if you want to do live monitoring, then you will probably end up there. Yeah. Yeah. Mm-hmm. Yeah. Right. So the question was any suggestions for basically like digging into particular kinds of malware, for example, like CNC families or C2 families, right? Yeah. Or. Oh, right. I see. Like okay. Yeah. Yeah. So it's. That's a great question. So some of the packages out there will detect certain kinds of C2. But the more interesting one is probably like if you can think of a particular one to then map it to like how you would detect it in Zeek. And I don't have particularly strong recommendations there. Yeah, like we could go for a beer and there would be lots of fun stories. Like back in the 2010s, sort of, we dug way into botnets as part of research work still, and that was all done with Zeek. But that was because we had the time to dig into like how botnets were speaking command and control. There isn't a one-size-fits-all solution, for sure. Like, it depends on how these guys build their stuff. But what I can tell you is that if it's some combination of, something DNS-based, some connection pattern, you definitely can detect it. Like, there's very little you can't detect because it's sort of another sort of mantra or truism that's like, there's a fingerprint on the network, and you can almost always get it. And it's a great one to discuss further, actually, because it's usually also the reason why whether it's encrypted or not does not matter. This often comes up when people are new to this. Isn't everything encrypted these days? Why are you bothering, sort of, right? It turns out for that kind of stuff, you can still work just fine. Like, basically, different topic, sort of, but the concern about encryption has been out there for almost as long as Zeek has existed, and it's just fine. Sure, would we love perfect visibility into HTTP today? Yeah, sure, right? And I'm very sympathetic to any effort that tries to conceal, activity for privacy reasons and so forth. I think that's all great stuff. But for the kinds of analysis you want to do in Zeek, you usually can, because despite encryption present, you still have enough structure to sort of pick up that you can build C2 detectors and so forth. Yeah, okay, cool. Get on Slack, ping me, I can give you my card, like it's all easy to discuss. Yeah, cool. Yes? Right on. Mm-hmm. Mm-hmm. Yeah, right on. This is cool. So there's a. Yeah. This is a great one. Yeah. So I would need to know a little bit more about this one. There is a DHCP analyzer, and we've iterated on that one a lot because so much gets conveyed via DHCP these days, right? So it's really fun, actually. One of our, main early contributors, well, still, but sort of key, developer, Ceph, like totally went off on DHCP for a year or so because just there was so much in there. And it, I think, depends on the exploit is the short answer, to which extent you will be able to see it in there. If it's literally, as easy to spot as an unusual field length, totally. I was chuckling when you mentioned this because we use a bunch of fuzzing to test our own parsers, and the stuff they throw at you, you wouldn't believe, right? Like, surely you will have an email address that is 10K long or stuff like that, right? Like it's, and then you have all of these discussions like, well, what do we do with that? Like, should we, like, where do we draw the line? Like, now we don't parse it anymore, right? And then you do experiments. Like, we checked the other day, like, what's the longest email address you can send into Gmail? Like, it is long, you know? Like, it's all pretty funny. So some of those things have no very good answer. And it's this old, you know, be liberal in what you accept, sort of. Like, we try to parse as much as we can, but sometimes you have to draw a line because, yeah. Yeah. Yes. Yes, this is true. And I would never deny the value of a PCAP for that, right? Like there's a reason why people want that. It's just, in our experience, virtually never paying off that you do bulk PCAP capture, like maybe for a very short time window, but with modern networks, even that, you know, is hard. So yeah. On the flip side, a lot of the signature-based intrusion detection systems, I think, really like that idea that when you have a signature fire on something, give me, you know, for that flow, like that packet and maybe a couple before, and then it usually gets fun because implementing that is challenging. But that's a nice idea. It makes sense to me. Like, as an analyst, I'd also want to know, like, okay, this weird byte pattern matched what was actually in the packet, because maybe it's sort of off a little bit, or yeah. So that's tricky. Yeah.
I think DHCP is a particularly good example because in a normal network, almost all of the DHCP traffic should follow very, very repetitive patterns. You've got the same
That's right.
employees
That's right.
and the same devices coming out of the network all the time. If you can filter out that and say anytime there's a new thing, maybe this is a place where AI, LLM type
Just testing, testing. Can someone in the back? Oh, no, that's clearly. do this, you can hear me in the room, so I think we're probably okay.
Hello, welcome to room 101. This room is sponsored by Spiderbat. Spiderbat's platform for cloud native runtime security shows you exactly what is happening and secures your Linux VMs and Kubernetes clusters throughout your software development lifecycle. Visit Spiderbat's booth to see it in action.
All right, so those of you now should hear me. All right, excellent. So I see people filtering in, so I'm going to give another couple seconds. But my name is Greg Prosser. As it says in the slide here, I'm a security engineer at Meta, and I'm on the Red Team operations group. And this, I'm specifically on the operations group, which is the part where we do end-to-end exercises to test our defensive teams. I'll get into it as I go through the slides, but I'm here today to share the perspectives of an outsider to red teaming. I was recently on what you might call a defensive team or a blue team, and I'll explain a lot of these terms as I go through. And I recently switched into red teaming, and having been on both sides of that fence, I'm hoping I can share some lessons and some thoughts and some things that I've reflected on as I've gone through this that you can use to make sure that your two teams, if you do have two teams or if you're dealing with the opposite side, can still stay friends, because you get the best benefit when your security engineers are working together, not always against each other. And I say that even though I'm against most of my security engineer friends. So anyways. So what we're going to talk about today, this is briefly what I just said. We're going to talk about what a red team is and the exercises that I'm talking about and the objectives on that and what we do. I'm going to talk about who am I and who I was, because that's relevant to the conversation. I'm going to talk about how, spoiler alert, I spent many years at Meta being a SRE or DevOps person. So for those of you in the room without security experience, there are some lessons that you might pick up from my experience from that point of view. I'm going to talk about how we do our red teams and things that a lot of people probably actually don't stop and think about when they see the end result of a security exercise. Certainly, if I look back on the conversations I'll show you as I go through my notes here, I didn't think about it, and so I think that it's a common perception to just assume that everything is great and rosy when you see the end of the exercise and you don't see all the stuff that goes into it. And I'm here to talk about some of the lessons I've picked up from that. And this goes into the perception part where I talk about reflecting on what prior me thought after seeing the end results of these red team exercises, like how can you use the perception that might appear to help keep people stay friendly at the end of the day. I'm going to tell a story about my first operation on the red team. It was about a year and a half ago now, and it was quite an experience to figure out exactly, coming from an SRE background, how I thought these red team people were just hacking things all the time, and it was an interesting awakening experience. And then I'll go back and I'll recap some of the stuff and I'll wrap up and talk about what you should probably be doing to take these back to your teams if you have a red team or if you have offensive people dealing with contractors, whatever your situation is. So for those of you in the room who aren't intimately familiar with this with what a red team is, or for those of you who are, you can probably tune this part out. What is a red team? So in security, we often think of the people that do security work inside a company. Usually you might have, you're probably familiar with your blue team. They're your incident responders. They're your people who are securing your servers, doing that sort of work to keep things safe. They're responding to alerts and making sure things are configured securely. We have this concept of adversarial testing or using vulnerabilities or penetration test or anything like that. That's typically what we'll consider the red team. They're the offensive team. They're coming at you instead of trying to defend your organization. If you don't have an internal red team or if you haven't dealt with one before, a lot of people are probably familiar with a lot of the sub-concepts here, such as like penetration testing. You might have retained a penetration test firm or seen a report to talk about like what vulnerabilities are found in your software. Red teaming is quite similar to that. You might be familiar with vulnerability research, where there are people, even in the open source community especially, where they'll do research of a certain application or a certain technology and figure out the weaknesses in it, file issues, get them fixed, anything like that. When we talk about a red team and we talk about the day-to-day stuff that I do as the operations group, it's a good mix of all of those things. In our team, it's kind of what we like to think of as a test of the full security stack. And so what it means is we're doing, bless you, penetration testing aspects, like we're breaking into systems, obviously. We're doing a good amount of vulnerability research. We're trying to figure out the vulnerabilities of the systems we're trying to get into. And we're rolling these all together into what we, usually leveraging those particular attacks, those techniques, to get unexpected access to something. And then the key part of what makes us a red team operation, and I'll get into this in a bit, is we're usually escalating this to the point of triggering a response. So for those of you with some background in the room who might have been in SRE, have DevOps people you know, people who run operations stuff and manage servers or whatever, they're doing failover testing. If they have two databases, an active and a passive, they're gonna switch between them to make sure everything works properly, and they want to do it in a controlled scenario. They want to find out their runbook or their documentation or the configuration doesn't work in a situation where they can recover quickly, not in the middle of the night at 2 a.m. when your pager goes off, right? And the same concepts can apply to your security organization. So your security organization has a list of runbooks, a list of documentation, where they're going to find the key logs you need in an incident or how to disable an account, for example. And you actually want to make sure that those documents are up to date when they need them in the point of time. You don't want them at 2 a.m. when their pager goes off being like, man, how do I stop this attack that's actively going on? And so that's what I talk about when we get to the response situation here. So why do we test response? I just talked about that. We want to make sure that those playbooks are up to date and everything else. Essentially what you're trying to think of is you're giving practice to your people who are doing incident response. In an ideal scenario, and I realize that saying this, most people are probably not in that ideal scenario, you are going to have your incident responders not responding to big incidents all of the time. And so the situation in which they do, you still want them to be sharp and ready to get there. You can kind of think of what we do in the red team in an ideal situation, kind of like training a prize fighter. Your prize fighter in this case is your defensive team, responding to incidents, fending off people, configuring your servers, right? If you have a red team or if you have adversarial exercises, offensive security things, what you're trying to do is you're doing those training exercises. If you come in too light, your incident responders are going to be bored. They're not going to learn anything. They're not going to see the attacks in the outside world. If you come in too strong, if you're finding a whole bunch of like 0-day vulnerabilities and throwing them all at your defensive team, that's not fair either. And you're going to tire them out. They're, again, not going to learn anything. They're not going to want to collaborate with you. And they're still going to be unprepared for anything that happens in the real world because the vast majority of what they're going to deal with is not necessarily going to be that level of attack. So in an ideal situation, in this sort of training exercise, you want to come in the middle. You want to have them prepped. You want to have something realistic. You want to look like an attacker that would actually do something to your network and do an attack that is relevant to you as opposed to something that isn't. If you don't use email on your day-to-day basis, running a phishing test is not actually going to prove anything to you in that particular situation. The interesting part about that, and this is what's led me to give this talk, is that sort of attitude can lead very easily to an us versus them mentality. And this is certainly true in the slides I'll come up to and what I've experienced in the past. A lot of times, if you are not directly involved in the response, maybe you're just an SRE helping on your security teams, for example, configuring something, and you're on the sidelines, you're not responding to an actual incident, you see the end result. You see someone broke into your system and did X. You see someone walking away with a bag of money, and it looks super exciting. But you don't end up knowing the prep time that went into that, and so you end up thinking the people who just did that like won, and you lost. And that's not really a helpful scenario or a helpful thing, and it's certainly not what we practice in our red team. We want it to be a fair fight, and we want people to walk away and learn things from that, right? And so you don't want that us versus them mentality. You're there to help strengthen that relationship and make it better. So you don't want them viewed as the enemy because then they won't want to work with you. Like, how many conversations do I start on a daily basis with people in the company and they look at my title and they go, wait, is this a red team? I don't want to talk to you. I don't want to tell you about the systems I'm working on. You can't see my documentation. That's not really fair. You want everyone to work together. You don't want it as adversarial as it seems to be. So I'm about to talk to you from the perspectives of the red team, but what if you have none? So don't feel bad. This isn't super uncommon. I'm from Meta, obviously, and so we have a pretty prepared blue team and a response team that can respond to a bunch of different incidents, and we have to all the time. You have to be an organization of a certain size, and you have a mature enough security organization for these exercises to make any sense. If you're a smaller organization, you're probably retaining a pen testing firm, doing one-off targeted reports or something of that nature. Just because your response team is not as practiced in that, this is not something they have to think about. If you're in that situation, there's still a lot of lessons you can probably take away from the conversations I'm about to have, because you're still getting results, you're still getting people breaking into your networks or something like that. The difference, the main difference between what I'll consider as a red team exercise and some of the other stuff I talked about, like a penetration test, is there's a good amount of an element of surprise in a red team operation. And I talked about the response part, and that's key. They don't know we're coming. So if you retain a pen testing firm and you're like, can you please look at this application? The engineers who manage that application, the security team who secures that application, they know it's about to happen. They know if they see something in the logs, oh, that's probably the pen testers going away. In our particular situation, when we're trying to manifest a response, they don't know that. They're in the dark, they're catching us by surprise, and that's key, right? And so that's one of the main differences. But the lessons I'm about to talk about probably don't necessarily need to rely on that element of response or that element of surprise. Trying to remind myself to slow down and breathe, and it's not going very well. Okay, so this is what we have is, so at Meta we have these internal profiles, and you can look up any other employee in the company. People are probably familiar with something like this. This is a picture of my internal profile probably from around 2017. And so I joined the company. I was a sysadmin, DevOps, SRE sort of situation. We call them production engineers. And I had been doing so for about 10 years. I had like an amateur security hat on at the previous companies I was working on. I was doing a little bit of security stuff. And when I was recruited and joined Meta, I was recruited as a production engineer. And as I said, they do our SRE and DevOps. The production engineering team is a large organization, but it has individual pods or teams that focus on particular things. So you might have a production engineering team whose job it is to maintain our cache servers. You might have a production engineering team just like keeps the website up and things like that. I joined the company and I joined the PE security team. I had had the amateur security hat on for a while, and I was like, let's give it a shot. While I'm here, there's a bunch of stuff I can pick up and learn from that. And so I joined that team. And our first project, as an example, was maintaining SSH for hundreds of thousands of servers and tens of thousands of engineers. Sounds kind of trivial, but when you get to that level of scale, you do cool things. One of the projects I worked on and still used to this day actually is we used SSH certificates rather than keys, because if you have to check 10,000 keys at sign-in, it's going to take quite a long amount of time. It's pretty sweet. I'd never thought about it before, and it was a fun project and a lot of stuff to learn. And we maintained it from that SRE point of view, but obviously this is a core security system across the fleet. Like, you're touching SSH on all of our servers, right? This is important stuff. The reason I mentioned that, well, actually, it's important to note that the PE security team over a couple of years and throughout time, eventually just became responsible for the security posture, we say, of all the servers that we call production. So every server you're talking to when you're loading Instagram or Facebook or using your Oculus or anything of that nature, you're talking to something that's in the purview of PE security. It's a bigger team now than when I joined. It does a whole bunch more stuff. The reason I mention that is it gives some context to what I was doing in the past, right? And so I was doing SRE DevOps stuff, pretty cool. But I was essentially, if you think about it, part of that blue team. And so I wasn't responding to incidents. I wasn't looking at logs or triaging anything of that nature. I wasn't, in the heat of it when the pager goes off in the middle of the night of a security incident, unless it involved the SSH configurations I was rolling out or anything like that. So I was part of the blue team, but I was behind the scenes. So I was like helping out, not necessarily part of them, but not part of the red team either. Like on the good side, I used to call it before I switched sides. Yeah, and so not necessarily the blue team, but related enough to be involved and plugged into all the things going on, more from the sense of like when something happened, I'd probably get some of the findings that happened or some of the lessons learned from that incident applied to the stuff that we were running eventually in the fullness of time. This is me now. This is, 2021 when I took this, when I started the slides. I joined the offensive security group. I'm now a security engineer, and I put offensive in brackets on this slide because I think that's an interesting perspective for me. I joined a team of red teamers who have been doing this stuff for many years. And me coming from an SRE DevOps background, I wasn't an expert on this. I didn't really know what I was doing from an offensive point of view. I'd followed along for a while, knew the general concepts, but I actually considered myself like a rank amateur in terms of the level of stuff that happened on this team. And this is relevant for the rest of the slides. I'll get into that. I became a member of the red team operations group. So I had someone before this slide talk about the offensive group. I mentioned earlier we do penetration, or there exists like penetration exercises, vulnerability research, all those sorts of stuff. The offensive group is a group which has all of those offensive security concepts. So we do all of those things, and it's all within our group. My particular team, the operations group, is where we do those end-to-end operations that I talked about earlier, where we're using the research or the penetration test techniques or whatever we're going to do to get access and do an end-to-end operation. So we'll pick an objective, we'll pick a goal, a system to target, and we'll do whatever we need to get to that point. And again, remember, I've been surrounded by people who have been doing this for years, so I have a lot of helpers who help me stay on the offensive security lines. So the interesting part that I didn't know when I joined the team, as I mentioned, I was kind of like around security enough to see these things happen, but not directly involved, is I didn't quite understand exactly how much research and preparation goes into a red team. And this is kind of the crux of why I'm giving this presentation. I would argue that if you have a team that does a similar thing, or if you've read red team reports or vulnerability research or whatever, you're probably just seeing the end result. You're seeing the vulnerabilities they found, you're seeing their findings, you're seeing the evidence that happened. You're seeing the giant vulnerability websites that pop up and everything, the response that happens as a result of that. But you don't know how much research went into making that happen. And so when we start a red team exercise, so a little bit of background here, we're an internal red team. And what that means is we have access to like the source code, the wikis, and even the engineers, if they'll talk to us, as I mentioned, it's sometimes a little adversarial. And so we can do a lot of research to come in and know where we're going to land and what we're up against. And so what I mean by this, again, if you're an SRE background, like maybe you have a particular service that does a particular job, and maybe it runs out of memory at 11 p.m. every night and crashes. and your Band-Aid solution is cool, I'm going to restart that at 10 p.m. We're going to find that and evidence of that happening in the system. We're going to know that happened. So we know the rough systems you're using. We know their weaknesses. We might find evidence of that bug, a task, or a wiki page, or something of that nature. And we're probably going to find out the mitigations you've put in place. So if we're talking about if you're gluing various systems together and there's a security boundary there, we probably know that that is a common weakness that people are going to go up against. And we know the mitigations you've put in place to make that not an obvious vulnerability. And we do that through a good amount of research. The interesting part about that is we usually, once we find these mitigations rather, we're also going to find your detections. We're going to find the places that you are going to watch to see if something is suspicious. If that system does crash, we probably know who's going to get paged, who's going to get the alert. Maybe we found their playbook that tells them what they're going to do to respond, and it helps us plan our exercise so that we are in control of like what happens. So if we're coming in with that vulnerability in your service and it crashes, who's going to get that alert and what are they going to do? And this is relevant because like if we're testing a security thing, we don't want necessarily a bunch of deep dive maybe at some points, and so we're going to structure it in a certain way. We're going to touch this system, whereas we know if this one ever crashes, this is bad, and we'll save that one for last because that's going to trigger our response, right? This is the level of stuff we know at the end of that research. Again, going back to what I said earlier, a lot of people don't see this. They see the end result, they see the big bang thing, they don't know the steps that led up to this, and this is an interesting thing that can lead to that us versus them mentality. So I mentioned I'm an internal red team, which means I have access to all these things, the source code, the wikis, the systems, whatever you're going to do. If you're not doing this, if you're a penetration tester or something like this, you're probably having access to a lot of this anyways. You're just doing more guesswork. We still have to do guesswork because everyone knows that writing documentation is not everyone's favorite job in the world. It's probably out of date the moment you put it down. The same thing applies to when we're trying to figure out how the system works. We also are not going to get the newest information. But your penetration testers, your other security people, they're doing what they can to learn from OSINT or like open source intelligence. They're looking at your systems and seeing what your DNS names exist, common ones. They're seeing where your infrastructure sits. Are you AWS or GCP? They can do all that even though they might not have access to the same things we do, but we are the internal team and we can see those things. So the interesting part about this is after we've gone through this and after we know the weaknesses, the mitigations, all the detections, we know who's going to get paged, we know your security systems, we end up looking like this, right? We can dangle that operative into the middle of the vault where all the money sits, and we know that if I put my hand up over here, I'm going to trigger this laser, and my hand down over here, I'm going to trigger this one. And ideally, I know who is going to respond in the event that I do those things, right? We have a plan. We have imperfect knowledge as well. One of my manager is common. One of the quotes my manager commonly says is, "Everyone has a plan until they get punched in the face." Going back to that boxer analogy, right? And so we think we know, according to the documentation that existed when we found it, what will happen when we trip that laser, but we don't really know. And so we get imperfect knowledge, but like we think we look like this, and this is going to be awesome, right? This is what we see at the end of it. So a little bit of context of the stories I'm about to tell. We have an internal group called Red Team Operation Debriefs. It's as boring as it sounds. The red team reports we write and the findings we generate end up going into this group for people on security teams to consume and understand what's going on. This group also serves a second purpose, though. I talked about driving response and the things that we do to make sure the security team is actually responding to us and generating an incident and things of that nature. And I talked about how we do that by surprise, right? What will happen is just like if you're like a person responding to a pager for a system, you're going to get alert. You're going to be like, that's suspicious, but they're not going to know it's the red team. They're not going to know what's going on. And so this group also exists as a pressure relief valve if things get too serious. So if our responders are like lost in the woods, they don't quite know what's happening, or maybe they're doing too good a job and they're about to call like the authorities to actually have us arrested. We don't like getting arrested, obviously, it's not really productive. We'll actually drop, the way we announce this to the other team is we drop like an image into this group to let them know that, oh, this was us, and they can sort of calm down and relax and we can deal with the rest of the red teaming process. And so as the blue team responder I talked about, well, blue team not responder earlier, I was talking about the person who helped like maintain the production servers. I was a member of that group and I knew roughly where these things going on. And so the next slides I'm going to talk about come from the context of, oh my goodness, an image just dropped, there's a red team going on, this is exciting, right? So this is a screenshot from 2019. I was firmly in my production engineering days, and an image, just like I had talked about, had dropped. And I knew enough of the red teamers as friends to sort of get the crux of what was going on. They wouldn't give me any super secret details, but they would let me know what was going on. And so I knew they were doing something, and I saw the image, and I messaged them. I said, well, your op is done. And they said, yeah, well, And I said, well, did you get detected? And they send back a face, right? And they say, and I asked if they haven't yet. That's really hilarious, nice. And they said, no, it's been weeks, right? Now, I want to talk about the different perspectives, and there's a reason I've highlighted this red and blue in the slides here, the different things you can take away, and how I reconsider this now that I'm on the other side of the fence. So 2019 me was like, oh man, the security team didn't see them in your environment for like weeks? How is that possibly the case? Like, what's wrong with our security organization that no one noticed that this was going on at any given time, right? And it's interesting to think of, like, you don't want to have, the instinct I had was to go and say, well, there must be a defect somewhere. There must be something wrong for that to have happened. The interesting part about now that I've joined the red team is that when I talked about earlier, when I talked about that research and I showed you the picture of us dangling into a vault knowing all the right things, this level of sitting there for weeks and not having tripped the alarms yet, that's roughly to be expected, right? So the reason I call this out is because the red teamer at the time who was talking to me probably had that perspective and didn't think to say, oh, well, it's not as bad as it looks. We knew all this stuff. And me, I didn't have any idea that I should ask that sort of thing. I've only seen the end result. I know they weren't caught for weeks, right? And so it's interesting to consider the different perspectives from both sides of that conversation, both equally correct in their own minds, ending up in the wrong spot, right? The truth is somewhere in the middle. Maybe they should have had detections in all the places and all the files they would have seen, they would have caught them, but then maybe the system runs horribly inefficient, so what's the point, right? And there's a balance to be struck there, and we knew exactly where to step or not to step to not have been caught, right? And so this is something that most people don't see unless they stop and think about it or have been on the other side, so to speak. Both of us have like entirely different perspectives walking away from this conversation. So this is another one from 2020. Actually, this is the same person. Another image dropped, and I was super excited. Another red team happened. I can find out what's going on. What happened this time? I asked what happened, and I get the response. He says, between us, it was fake Flash that dropped VS Code malware. And I look at that and I go, oh my goodness, it's the year of 2020. How on earth does fake Flash still trick people into running stuff in the organization? How is that an entry vector that still works? The part that I didn't know, well, there's several parts that I didn't know. First of all, that whole fake Flash thing was the smallest, tiniest bit of that operation at the very beginning that didn't actually matter very much. Those of you who are in a security team probably know that, even in a really good organization, you have super talented engineers, you're still going to have that 1% of people who might be tricked or might not be operating at their best that day who are going to engage with that, and they're going to get that sort of infection, right? So even though this is uncommon, this is rare, this should be harder, it's still going to happen, and so it's not unrealistic. And so talking about the things you want to practice, this is one of those things, right? The other thing I didn't know is that we have a technique in red teaming called assisted executors. And so we have a lot of things that will take a decent amount of time to come to fruition if we didn't do this. And what I mean by that is if you're doing a phishing attack and you're depending on that 1% to click on your lure, and maybe you don't know which 1% it is and whether it's actually going to be relevant to the exercise you're trying to do, you end up cheating a tiny bit. You find someone who will get that phishing email and engage with it just to have a plausible story to go through. And this applied in this case. The person who installed that fake Flash, they didn't do anything wrong. They were being asked by the red teamers to do that, to kick off an operation to start that thing, right? And so when I say this is the most minor detail of the operation, it was super minor. The other thing that I didn't know, and I've learned this since joining the team, is the second part of that sentence is actually the key thing. We dropped a VS Code malware thing where we landed on a machine and hid in the VS Code process. That whole thing, the amount of research involved in setting that up, the whole technique of doing it, all the exploitation stuff, that took the team weeks, if not months, to perfect that and have that work reliably enough to be used in that exercise, right? And so here I am, again, talking about the different perspectives. Is the red teamer has told me what's going on, and they have no idea, like I'm focusing on this. Well, they do know I'm focusing on the fake flash bit, but they, they're probably agreeing with it at the end of the day. Why is this still a thing that we have to deal with in this company? But like, I don't realize that VS Code malware is actually the key part. And they don't think to correct me because they've spent just weeks planning, and this is just part of the operation they've gone through, right? And so we both, again, walk away with entirely different perspectives. I'm walking away thinking, man, our organization must be so interesting that we still fall vulnerability to these things, right? When in reality, this has been like exquisitely crafted specifically for this to happen, and we would have found another person to engage with this if we didn't. I take it for granted that this all worked 100%. I see the end result. This happens after the image has dropped, so I know something has happened. This is, it all worked, but it took tons of iteration to get to that point. This is a quote from JFK. I believe he was talking about the CIA. It's not super relevant what he's talking about in this case, but this applies equally to your security teams. Your successes are unheralded, so no one talks about the 10,000 hackers that your firewall actually kept out, or the attacks that didn't happen because you have defense X in place. Your failures are trumpeted. We care about the one thing that does actually get through. It's a common thing that I've heard before that defenders think in lists and attackers think in graphs. Attackers have to find the one chink in your armor to get in the front door, and then they can maneuver through different things. Your defenders have to secure all the things all at once, all the time. And so it's a hard problem to solve, right? And this is especially true here. I was not directly involved in the incident response here. I'm sort of following on at the end, and I'm jumping on the bandwagon of the exciting red team that happened at this point, and I'm kind of like trumpeting the failures that happened, the red team that happened to succeed at that point. And that's not really a super helpful behavior. You should talk about all the things they had to get there, but most people don't end up seeing this. So like, when I saw the image drop in that group, and I saw that there was an event that happened, and I talked to the red teamer, I don't think like this. I just see this. I see the end of the operation. I see that red teamer running out with a bag of money, finding the password file, the encrypted database, whatever is going to happen. I don't see the amount of planning that got to the point where they could do something like this or think about that. I only see the end result. And I see someone taking a picture, but I don't know what slide they're taking a picture of. Okay, cool. All right. So, like this is when I before I switched to the team, that's exactly what I saw. I saw these badass hackers, taking all the monies and doing all the things. I'll go join them. Little did I know that I was about to join, a research factory at the end of the day. So I talk about the amount of research and preparation we have to do, and I want to give some clear examples of things that most people would not think about when they think about exercises like this, and would go unnoticed, and like are significant time sinks now that I've crossed the fence. What you see here is a common example of something called a kill chain. The details don't matter too much, but these are a number of things that you have to do to have a successful operation. The exfiltration at the end would be that bag of money. That's the end result. That's something exciting that happened. But the first 6 steps of that diagram are equally important. You can see there's a pathway there to get to that end result. And me, in 2019, when I see that image drop, I don't think of any of those things. I only think of the end result. Here's some examples. I talk about the VS Code malware and landing on a machine. The interesting part about that is not only do you have to get a piece of malware in an environment that works and runs, you typically want something called command and control, right? Having this run, pretty useful. Maybe you get one shot at grabbing something great. That's usually not what you want. What you want is repeated access. You want like remote access into the system so you can do interactively what you need to maneuver your way around, get to other systems or anything like that. And the way we do this is through a number of, we have a number of different ways of doing this. If it was straight up over the network, that'd be pretty obvious. Maybe we have stealthy channels, like we can use DNS, or we hide messages in ping, or we do something really sneaky like that, right? There are a ton of different ways we can do command and control. In fact, we spend an inordinate amount of time on command and control, but that's beside the point. And we have to think of these things, right? We're going to go into an environment and we're doing that preparation, we're doing that research. We have to figure out which one's going to work, right? Because we're developing that payload, that malware that's going to live there, and we're not usually going to have the opportunity to fix that in post, right? So we have to land that in there and have a communication mechanism that's going to work. And so when I do an operation, let's say I'm going into a particular environment, I have to figure out if I need to use the DNS channel or the ICMP channel or TCP or whatever, what's going to work in that environment. The end result is that I find the one that works, and I do enough research to get it up and running, and everything works great. But no one talks about the iterations and the research I did to get to that point, right? No one talks about your security team is good enough to catch the DNS one, so you have to find an even more covert one or something of that nature. And so there is like success baked into that for your security team to get to the point where you have to be covert or sneaky, right? Like you don't get that for free. Another example, I used the acronym EDR, and I forgot to change it on this slide. EDR is Endpoint Detection and Response, I believe. Doesn't matter. It's the next evolution of AV that is on most enterprise workstations. And so when I talk about running malware, it's not exactly trivial to just like run malware.exe on someone's machine. There's typically a bunch of system processes that are checking to make sure malicious things don't happen. There's a bunch of access pattern checking that happens behind the scenes. And you have to, manipulate your malware that you're going to use enough so that it hides from that and still accomplishes what you're trying to do. But the key point of that is no one talks about the iterations that you got there. You ended up at a final result that did run and did succeed in what you wanted to do. You got control, that's great. But like the 1,400 other builds that you had that failed in some interesting way don't get seen as the end result. They may end up as a line item in your report, but they don't get called out. And again, that's something that your security team is responsible for maintaining, has set up and done, and that's work that doesn't get recognized when you see that end result, at least by default, right? And so it's easy to forget, as a red teamer especially, that you don't see those as the outsiders. And it's also easy to realize, to forget, even if you're a responder, that a ton of that work goes to this point to have this succeed, right? And so even in some cases, the responders see the end result and they go, oh man, what happened, right? But they don't know that there's been like tons and tons of research to get to that point. So I'm going to talk about when the first operation that I was on, and one of the first lessons I learned when I was on a red team, in terms of my first operation, sorry, same words. The production engineer me met the offensive security engineer me in my first operation. So this is it's January 21. I've joined my the red team, the operations team, and I'm kind of a little bit freaked out about it. I mentioned earlier, I put the offensive in brackets. I'm surrounded by people who have been doing offensive security for a while. I'm just this lowly DevOps guy. Like, what do I know about offensive security? Are they going to find me valuable enough to keep me on the team? Something of that nature, right? All those thoughts are running through my head. And so, I end up, feeling a little bit trepidatious about myself. I'm unsure. The next thing, again, this is the first operation as well, so you've got the first operation jitters, I guess I should point out. I find out shortly after that we're operating in production. So I skimmed over it earlier, but production refers to the servers that will actually answer your request at the company, like when you're browsing Instagram, Facebook, things of that nature. But more importantly, when I was a production engineer, when I was doing those jobs in that, I was operating in production as well. I was securing production, right? And so I feel a little bit better about that. I'm a little bit more excited. I'm a little bit more confident that things are going to go well because I know what I'm up against. And that said, I'm now defeating the things that I had spent years set up, and so there's a little bit of fear involved in that. And I'm like, oh man, this is actually going to be hard because I know we've done X, Y, and Z. But at the end of the day, we're operating in a place that I'm a little bit more comfortable. I feel better about it, okay? I'm less terrified than I was at the beginning, feeling a bit better. So after staring at some stuff for a while, doing a little bit of research, probably a couple weeks of research, I end up finding a configuration management misconfiguration. Those were a lot of big words, but essentially I found a key vulnerability that let us continue. I was doing a bunch of wiki research and reading some code, and I'm like, oh, we can do this and this and this, and we'll have access, and this will be great. And so now, not only am I feeling good because this is in production, I've shown a little bit of worth, and I know what I'm talking about. I've done some research. I know how these systems work. I've come up with something. On top of that, I find out that this actually leads to root on all the servers in our environment because it's a configuration management system, right? So there's a lot of elevated stuff in this environment. I'm feeling absolutely fantastic, right? And so I've gone from, way back here, my first operation, a little bit worried, and through all these sorts of things, I'm feeling on top of the world. I feel great. I've joined this offensive security team. I'm doing offensive security work. The things I'm doing are useful, interesting, impactful, I guess you should say. I'm feeling better about it. I feel like I've just won the jackpot. All these things have come together. I didn't think I would get the opportunity to do these things like my first time around, as an example. I thought I have to, pick some stuff up as most people do on a new job. This is great. One of the other things that's cool about this is like, I've spent years inside the company doing this sort of work, right? And so if you're a DevOps person, like you're probably familiar with like putting the duct tape over the thing that's broken in the system to keep it together well enough that it doesn't break for at least another couple of days, or trimming the log files or something like that to give enough operation room for another couple weeks, right? But I've spent time doing this in the security spaces, and more importantly, I know the really great targets across the company when it comes to security-related things, right? Because I was on that PE security team, I know where the key logging sources are. I know where the interesting servers that might exist that do specific operations. I know where the secret store is and all that sort of stuff. And I'm like, this is cool. I'm in production. I found a cool defect. We have high-level access. I can totally use this skeleton over here that I hid in the closet years ago to go and find the particular thing. Like there's all these cool targets that I can now attack as an attacker that I'm on this side. This is great. If I think back to 2019 me, when I used to see these red team exercises happen, this is how I used to think. They find some way, they get root everywhere, and everything's great. They just bust up everything, right? And I remember I was having a conversation with my operation lead at the time when we were talking about the rough plan, the one we formed before you get punched in the face, as I said. And my lead sort of looks at me and goes, that's cool, found this, that's really awesome. And I'm like, yeah, we can go after this. We can, that key server over here, we can do that. And he's like, hold on, we can't do any of that. And I said, well, I mean, why? We have access in here, we can do just these cool things, right? And they said, well, because you have to think like a threat actor. And I paused for a second, and I said, I'm sorry, I have to think like a threat actor? Can you elaborate a little bit? What do you mean? And he says, like, the people that are going to break into your organization, the attackers, they're not going to have a map that looks like this. They're not going to know where all those cool secrets are that you spent years protecting, right? They're not going to be able to know exactly what cool thing to be impactful in this operation to do. They're going to be making guesses, right? And I said, well, that's kind of interesting. If you look at the faces slide earlier, like it took me down at least another notch or two in terms of the ability to leverage the thing that we had just found. But we couldn't go after those critical security services because if you think about it from an attacker's point of view, if you landed in this environment, you're not even going to know where to start looking. You might have some guesses, right? Like maybe you've done your research and Facebook uses, or Meta uses a certain technology to do a certain thing. You can go look for that, right? But what if, we've changed it over the last year and we haven't told anyone, right? Like you don't know this stuff for sure, and you don't have this map that tells you these things. You're probably just going to go for the quick win. I think in this particular operation, we ended up just searching for some, finance-related data or something like that to generate a response of that nature. But I was sitting there going, well, wait a second. Like, I want to do all these cool hacking things. And it's like, well, no, there's a story that you have to tell. I talked about the response piece earlier. I talked about having your blue teams be trained by these operations to prepare for these exercises. And I talked about how you have to do this with an element of surprise. If they know it's you, they're not going to respond in the same way. There's going to be no urgency, no worry to that. You're not getting the same sort of in-depth test of your runbooks and staff that you think you are if it's not like secret and covert or anything of that nature. The key part of that is you have to be able to tell a story. I talked about some of the things that an organization will face from a security perspective, phishing as an example, or malware served via a website or something of that nature. You want your security team to prepare to respond to things that actually happen. And so you want to be able to use those techniques that will actually be practiced in real life, right? And so me breaking in and using this particular vulnerability to get root everywhere, that's cool. But unless the attacker we're facing is someone who's worked at the company for 6 years, that's not a realistic attack that you're going to face in reality, right? And so this was an interesting message for me because I thought, red team, cool, you just go in there and you hack all the stuff all the time. But there's a whole element of storytelling that's involved in planning these operations and thinking about the response that, you don't think about by default when you think about this cool stuff. You just see the people running away with a bag of money, as I called out. And so here we are back again at the slide here where I talked about the 7 things you think about during an operation, and the first 6 being invisible. That's the main message I want a lot of people to take away from this when they see, when they're interacting with their defensive teams or maybe reading a vulnerability report or anything that happens. It looks really bad when someone gets hacked or some incident that happens, but there's usually a lot more story that happens to that, right? We can do the best security things in the world by unplugging our computers and leaving them in our desk drawer, and then no one can use the system we need, right? But that's not useful in your day-to-day life. You have to make some trade-offs, and sometimes they're going to bite you. What you're worried about and things that actually are concerning are patterns, right? You don't want the same red team to succeed over and over again. You don't want the same pen test to come up with the same results over and over again, right? And so keep these things in mind. Keep all that preparation in mind when you're looking at the end result of these operations. It's easy to forget those things. So, red teams look totally badass, but at the end of the day, it's only because of the amount of research we had to do. It's the prep work we do to get to that point. The other interesting thing is your blue team does hard work, and you should remember that. And so I talked about the amount of time that we have to spend on things like evasion of antivirus or EDR solutions or command and control of all those things. And I talked about the amount of effort that we have to go through to end up in a situation where our plan is actually going to succeed. And I talked about how people don't see that, but the reason that we have to do those things is because your blue team has done hard work getting to that point, right? If I go in an environment and I have to use like a really slow covert channel to make sure things are going to work or things are going to succeed, it's because they've blocked all the other paths that are going to work trivially, right? They've done some successful work to get to that point. It's easy to forget that sort of thing. No one talks about, at the end of the day, the malware that didn't run in that environment, or the things that were blocked, or the hackers that are blocked by the firewall. People only look at the successes, and that's not necessarily the best part. So next time there's an incident of that nature, dig in and try to figure out what sort of stuff had happened to get to that point. So I'm at the end of my slides, and the interesting message that I want people to take away is to think of, if you have offensive security teams, treat them nicely and realize that they're only here to help you protect your environment, just like you guys are if you're defending against them, right? At the end of the day, you're doing work to protect systems, and we're just helping you prioritize and helping you think about the things that you might need to do in the event of an incident. And yeah, that's my talk. Thanks, everybody. So I have some time for questions if anyone wants, but I prefer to take them up at the podium or whatever, so come up and chat with me if you have more questions. Thank you for coming. I will be at the Meta booth in 401 in the expo hall probably for the rest of the day if you have questions and want to go somewhere else. But yeah, thanks for listening, everybody, and I hope that you're nice to your blue teams.
Check, check. Mic check. 1, 2.
This one works too.
Yes, check, check. 1, 2, 1, 2. All right. Yes, this just has the on and off switch. Give it a second to turn on. Just right on.
Okay, welcome to Room 101. This room is sponsored by SpiderBat. SpiderBat's platform for cloud-native runtime security shows you exactly what is happening and secures your Linux, VMs, and Kubernetes clusters throughout your software development lifecycle. Visit SpiderBat's booth at booth 112 to see it in action.
Thank you, Paul. You guys can hear me? This is, all right, perfect. Yeah, well, thank you as well to SCaLE 20X. Thank you to you guys for coming and being here. And thanks to Firetail for the organization I work for sponsoring me to come here. And today, yeah, I'll be talking about the OWASP API Top 10, the top risks associated to APIs. We're going to be talking about the 2023 version, actually, the release candidate that was announced just a little under a month ago. So only the freshest stuff here. So a little bit about me. I'm Paul Mansour Geoffrion. I graduated from the University of Montreal in 2014 in international studies bachelor's. I then worked for the 4th Intelligence Company, a sort of Canadian Forces Reserves unit. Then moved on to sort of do startups, digital innovation, cloud security. Joined a cloud security posture management startup, Cloud Conformity, in 2017. That essentially helped organizations maintain their posture in the cloud. And then more personally, I'm a fan of gardening, space. I did an International Space University course over the summer, sailing and house music. So that's enough about me. Let's actually get started. But before we do, let's back it up just a little bit, maybe just a couple hundred years, and talk about some threats to the Industrial Revolution, or threats that were present in the Industrial Revolution, I should say. So yeah, highwaymen, stagecoach bandits. You can imagine if you're traveling city to city, you may be at risk of being stopped by some unsavory people and then robbed of your belongings or worse. Another threat, high seas pirates. Actually, the US's first overseas conflict. You guys didn't do that well with modern day Libya, actually. And yeah, some not so great stories out of that. But yeah, and then the third risk, well, the third sort of major threat, nation states, of course. So we've had a couple world wars, some more wars before that, and wars up to this day. Now, fortunately, we've mostly moved on from this, at least in the sort of developed Western worlds. Mostly, I say, there's still many, many exceptions. So now we're more in the digital revolution. So what are the sort of threats that we might encounter here? Well, obviously physical attacks on data infrastructure. Think about an AWS data center that gets attacked. There's a disruption that's going to happen necessarily. Further than that, there's disruptions to your operations. So digital disruptions that can include ransomware. You can think of the Texas power grid hack that happened in 2021, where an organization that was part of the oil supply chain was disrupted through ransomware, and sort of that led to some very long lines at gas stations and very high gas prices. And then third, the intellectual property theft. I think that one's pretty self-explanatory, but also asset theft. So you can think of, for example, satellites that get sent up to space. Oftentimes the way that those satellites get controlled is through, well, APIs or other digital means. So if that gets hijacked, then you can end up actually losing that assets. It can be satellites, could be drones, could be rovers, could be any sort of remote controlled assets. And then finally, personal identifiable information. That sort of theft leads to real monetary and reputational loss for businesses. So definitely not something to discount. So how did we get here? So we've established that the threats to today's industry are different than what they were before. They're also consistently changing. So 5 or 6 years ago, I was at the forefront of getting organizations safely migrated to the cloud. I saw all kinds of cloud infrastructure issues. So the issues aren't the same that they are today. Best practice, it evolves, right? It's an organic thing. Today, what we're seeing is that APIs are actually on their way to becoming the #1 source of vulnerabilities for organizations running IT infrastructure. So that brings us to the subject of today's presentation, application programming interfaces, the attack surface that connects us all. And then more specifically, the OWASP API Top 10. As I mentioned, today we'll be covering the release candidate of 2023. So there's some new things. If you guys were familiar with the 2019 version, there were some changes that were made. Still subject to change because it's a release candidate, so yeah. But only fresh stuff. So number 1. Broken object level authorization. So developers often incorrectly assume that authentication equals authorization. It's probably because they're both often just shortened to auth. So devs will assume that API calls will only be coming from good client software like a mobile app, and that will help them control the parameters of API requests, which will then make it impossible for user A to request user B's data. Now, unfortunately, that's just not how reality works. Any sort of predictable pattern in your app's data structure can be exploited by a malicious user. So if you're not using random and unpredictable values to identify your data objects, they can be predicted and so are much easier to exploit. So let's use a rideshare app example. Say a malicious user guessed your rideshare account user ID because they figured out that the IDs were sequential, like ID 101, ID 102, 103, etc. So the attacker could then mock a legitimate API call to fetch information about a legitimate user's ride history. That's personally identifiable information. You don't want someone to know about your ride histories. So essentially, this unauthorized user gained access to a data object that they shouldn't have had access to. If the rideshare app's backend doesn't check that this user is allowed to access that specific data object in question, then of course the API is vulnerable. So the mock request made by our malicious user to the rideshare app's backend would only go through if the mock API call is not properly checked for authorization. The user making the mock request is actually receiving the ride history of that they requested, then of course that's a breach. So an authorization check was definitely not made in this case by the application logic. And an object level authorization, that's been broken. That's the sort of vulnerability here. So if I haven't been clear, this is really, really bad. This is the sort of breach that security professionals lose their jobs over. User A getting user B's data is really, really terrible. So yeah, it's a good idea to use universally unique identifiers or globally unique identifiers to mitigate this risk and ensure that all your functions are actually checking for authorization. So moving on, broken authentication, the second one on this top 10 list. So this one's about user impersonation. Can a malicious user trick your application into believing that they're someone else? So there's a few common ways that this can happen. Credential stuffing is just using pre-made lists of usernames and password and then trying every single one of them out until one of them works. Another one is using automated brute force attacks against a specific user, where an attacker tries out different passwords or MFA tokens until they find the right one. Third, poor in-transit security, like lack of encryption, poor or just no hashing, putting auth tokens or passwords in the URL. This can mean or can make your users very, very vulnerable. So malicious actors can intercept that stuff and sort of just by sniffing the network for these API requests and responses can lead to a man-in-the-middle attack. Fourth, tokens or other credentials that are properly generated by the front end. So your front end is doing what it's supposed to, but then the back end is not actually using those authentication details. So they're never actually checked for validity, and just the back end assumes that everything's okay. And then finally, exploitation of deep links or other one-click authentication mechanisms. So to summarize, broken authentication it's essentially a malicious actor gaining access to a real user's rideshare account and then ordering for themselves as many rides and food deliveries that they can get away with. So some best practices to implement to limit your app's risk here: use minimum password lengths, rate limits API calls, don't rely on long-lived credentials, and implement CAPTCHA or other, like, are you a human type tests to your authentication services. So an easy example here of a breach, Optus, this is an Australian telecommunications company. They were affected by a breach last year because a network configuration change exposed 100% previously internal API. So this API was meant to be internal, and it didn't check for authentication. So security through obscurity is just, it's not good enough. So before we move on to the next issue, I want to be clear that these two first vulnerabilities, they're the vast majority of the causes of breaches to APIs that have happened at least in the past decade. So yeah, watch out at least for these two. The other 8 important, but those first two, vast majority of breaches caused by those. So moving on, broken object property level authorization. Again, let's use our rideshare example. So marketing team had a great idea. They want to show the world how diverse their rideshare apps user demographics are. So they're having the public website show a sort of rotating feed of user first names and the cities that they're from. So that's fine, right? It's nothing too crazy, stuff we've seen before. The problem is in the implementation. So they only really need the first names and the cities of the users, right? Unfortunately, the backend service that they're using is returning a complete user object, meaning it's much more information that they actually need. Well, why are they doing this? Well, unfortunately, it's just easier to develop that way. You take all the data, and then you just cherry pick what you need, the actual few fields that you need to use. Fortunately, the data, all the extra data about the user object is still there. It's only a few clicks away for someone with very basic technical knowledge. And unfortunately for our example rideshare company, the extra user data contains some pretty sensitive info, like a new field for bookmarked addresses, for example. And suddenly, it's not just a fun new addition to the website, it's a serious user data breach. So what could have been done to prevent this? A couple things. One, handle data sanitization on the server side. Only return what's needed to your client side. You've heard the expression need to know. Well, since the website doesn't need to know about a user's personally identifiable information, just cut it out before it's sent back as an API response. And also, maintain an API contract and make sure that it's being enforced. So the contract should have stated that user bookmarks are for specific scenarios that don't include the public website. So never send it back to the public website. Moving on, the fourth vulnerability. So this is unrestricted resource consumption. So if your API is being hit with so many API calls that your servers are made unavailable, you've probably done something wrong with the design of your API. So unrestricted resource consumption, this can lead to denial of service attacks, which have made the news on much more than one occasion. Hacktivist collectives, they love this because it's very visible, makes a very big PR splash, even though it's pretty easy to recover from these. So if a request can make a call for an unlimited number of records from your database, and your server tries to fulfill that request, it's going to affect the performance of your database and all the services that then depend on that database. Additionally, if a malicious user can send your server a 2 terabyte JPEG as their user profile picture, and your server doesn't handle that gracefully, it's going to have, again, an effect on service availability for legitimate users. So this is where rate limiting, pagination, and a transparent API contract come in. Rate limiting will prevent users from sending requests at a rate that is too quick for your backend to handle, and pagination will allow users to slow down their access to your database by returning a different set of results with each request. So items 1 to 99, items 100 to 199, and so on. So a clear API contract will mean users, including the team responsible for handling the client side, are aware of the limitations of interaction with the API. And at the very least, pagination and rate limiting will minimize the scale of any breach. So it's difficult to be completely safe from denial of service attacks. It's even more so difficult with distributed denial of service. Hackers can easily change which IP and which device ID that they're pinging your servers from, and that makes it really difficult to differentiate between what's a legitimate request and what's a fake one. So for now, it's okay. The more visibility that you have on your incoming requests, the easier it will be for you to sort of catch the ones that are intending you harm. Moving on, the broken function level authorization. So each API call made to a server is received and processed by a specific function, right, in the application. Before executing the code, functions evaluates the metadata that's been passed along with the API request. This data includes information like who's making the request, what type of request is being made, and where the request should be going. Now, if a user who requests a ride is the only one, it is the only one that should be able to interact with the function that handles payment processing for their account. The driver who's giving this user a ride should not have the ability to mock a user API call to the same payment processing function and change how much they're being paid for a ride, for example. If you're not using the principle of least privilege, though, principle of least privilege where you define a limited scope of user-allowed actions, then you'll be vulnerable to broken function-level authorization. So to avoid this, devs should use a granular access control system to define who is allowed to do what. So as a rider, I can modify how much I leave as a tip for a ride that I've taken. As a driver, I can view how much was left for me as a tip for a ride that I have given. So very clear sort of scope of permissible actions. So unfortunately, it's a lot easier to just write an application that treats all users the same without making the distinction between modify or view or any other permissible action. So this next one, server-side request forgery, that's actually a new one for 2023. This vulnerability allows attackers lateral movements from a public-facing server to internal-only resources. So this can lead to data exfiltration if the server can be forced to interact with third-party resources. So to help mitigate this, make sure that your network topography, meaning how you set up your network architecture, make sure that it doesn't let the servers that you use to fetch external resources then also interact with internal-only resources. Create a clear segmentation between those two types of resources. Also, you should be very explicit about what sort of URL structures and which ports should be used by external resources. If you can, it's a really good idea to use a whitelist or list of allowed IP addresses or DNSs. And then, as always, you should always validate and sanitize input data before it reaches your data layer. Also check outputs, but yeah, at least validate and sanitize inputs before they're sent back to data layer. Security misconfigurations. All right, so this is a rather large category. It can include configurations that are sort of directly about the API and its infrastructure, but it can also be about the application higher up in the tech stack or the infrastructure lower down in the stack. So these misconfigurations are often going to be part of vulnerability chains. So essentially, the idea of a vulnerability chain is that you're using multiple exploits in a row to gain access to the most valuable parts of the infrastructure that you're going after. So for organizations that maintain APIs, a single vulnerability probably won't cause a catastrophic breach. Unfortunately, usually hackers are going to spot more than one vulnerability from the OWASP API security top 10, and that's going to allow them to leverage the chain of vulnerabilities into a breach that has a much higher impact. Great for them, not so good for the security professionals in this room. So let's go back to our rideshare app example, a simple two-step vulnerability that would allow for like a chaining, to allow for account takeovers. Yeah, let's get into this example. So the first vulnerability in this chain will be in the login process, specifically logins through Facebook. A faulty implementation of the login mechanisms mean that the rideshare app's authentication step can be injected with the ID of an account controlled by the attacker instead of the true ID of the legitimate user that's being sort of attacked. So despite passing this Facebook login step, there's still 2FA in the way, right? So we've sort of exploited the first vulnerability. We still have MFA to go over as an attacker. So unfortunately here, we never implemented rate limiting for the MFA step. So a script could then sort of be used to try every single possible combination of a 6-digit verification code until, well, we're successful in our breach. So this was about vulnerability chains. Let's go back more in depth into security misconfigurations. So there's a very long list of areas where potential misconfigurations can slip through. So a few of the more common sources, let's get into them. One, using insecure transport protocols. Transport Layer Security, TLS version 1.3 is the latest version. It was released in 2018. It's the most up to date. HTTP methods. So don't allow for unnecessary HTTP methods on your endpoints. There are a lot more than you think. Just use the ones that you're expecting and allow the ones that you're expecting. Third, require the latest HTTP security headers. So HTTP strict transport security, HSTS, implement content security policy, and X-frame options. The fourth, overly descriptive error messages. Windows is notorious for this. To use an example, so Starbucks .NET server, that was an important link in a vulnerability chain. This led to a PII breach. This was reported by a security researcher. So like, make sure when your endpoints return an error message to not expose anything about how the underlying application works. Don't send back the full stack trace, for example. Keep it short, keep it generic. Still help the users in figuring out how to use your API, but don't give them too much information about how your application works. Fifth, enforce the use of HTTPS. I know this is basic stuff, but it's still vulnerabilities that we see present on infrastructure. Sixth, use CORS, cross-origin resource sharing, to restrict essentially the data flow to only pages or domains which your application should be communicating with. And then finally, infrastructure misconfigurations. This one is also quite a large one. Just follow the well-architected framework. I don't know if you guys are familiar with this. It's a framework about how to architect well in the cloud to make sure that your infrastructure isn't misconfigured. So eighth, lack of protection from automated threats, also a new one to 2023. So Ticketmaster actually was famously recently affected by this during the Taylor Swift concert ticket sales. So malicious users were able to abuse the Ticketmaster APIs to scoop up every single Taylor Swift ticket at what turned out to be bargain rates. It was all over the press, right? This was a fiasco. There was even a Senate investigation, if you guys remember. This is pretty recent. So you've all also been affected by a sort of automated Facebook or Instagram spam comments. We see them all the time. The point here is that attackers are going to go through very normal user flows within your applications and APIs, but they're going to go through them in a way that's exploitative. So at Firetailor Lab, we've researched and we've found that 90% of requests to APIs will be bots that are scraping for secrets or credentials in .env, git.config, GraphQuery, or other admin endpoints. So to mitigate this type of threats, OWASP recommends using mechanisms like device fingerprinting or user flow analysis to identify and block automated threats. So sometimes when I'm Googling stuff at a super frantic pace, I get redirected to a CAPTCHA page before I can actually get my results back. That's the sort of mitigation strategy that isn't too obtrusive to normal users, but would most likely vastly reduce the impact of automated threats. Second to last, so APIs are routinely use versioning to account for the sometimes conflicting priorities of development velocity on the one hand and support to legacy systems on the other hand. So despite releasing, for example, the version 2 of your API, you may still want to give a grace period to legacy users of the API's version 1, so that they at least have time to update their applications to work with that latest version and they don't have any disruptions to their operations. So in theory, this would be fine, right? However, in practice and given real-life time constraints, dev teams will often just make the decision to implement latest security best practices on the latest version of the API and just forget about updating previous versions and leave them running. So to at least be aware of what infrastructure you have running, what APIs are running, are sort of allowing connections to your application, many organizations will maintain an API hosts inventory. So let's make sure that we understand the distinction between an API contract and an API hosts inventory. So the contract is defined by documentation. It's often created through open API spec, and it describes how to interact with a specific application or service. On the other hand, an API hosts inventory will encompass all of the API contracts that are under the scope of the team responsible for the API's maintenance. So properly managing new releases also falls under the scope of assets management. You should always set up distinct environments for dev, test, staging, and production, and you shouldn't use production data in pre-prod environments. Aside from just being like a risk for additional data breaches, it exposes your internal users' data to your teams, and that may also be a violation of GDPR or whatever Californian equivalent there is. So improper assets management, this is often mitigated through operational controls. So you should categorize your public APIs and APIs that are meant for internal or private use. Make sure that your APIs that can interact with PII is tagged as such, and so is given special treatments. And if you have a deep understanding of the data flows and the connection between the services that comprise your infrastructure, then there's a much better chance that you'll be a step ahead of attackers' attempts to exploit your assets. So unsafe consumption of APIs, that's the last one, and also a new one to 2023. So we're clear that user inputs into your application are vulnerable to exploits. So what about third-party service inputs? So devs tend to trust, and understandably so, other companies' APIs more than their own users' inputs into their applications. The conclusion of this is that the devs are more likely to adopt weaker security standards for input validation and sanitization when it connects to third-party services versus just user inputs. So there's a lot of different exploits that can be achieved through this vulnerability, anything from data exfiltration, remote code execution, denial of service, can be done through a compromised integration to a third-party API. So the message here, I hope I'm clear, you should apply the zero trust security model to integrations as much as you do for user inputs. So imagine, for example, what will happen if Twilio or Stripe were breached. So a lot of companies that depend on those services, and all of their downstream integrations would potentially be able to be exploited through those breaches. So this is my last slide. I'm going to actually repeat this talk in a few minutes if some of you arrived late. We're looking essentially to partner with organizations that are building API reliant modern web applications. And yeah, we'd love to sort of get in touch if you guys have any specific struggles or concerns. We've built open source API security libraries we'd love to share. We'd love to sort of get your feedback on and see how it could be of use to you guys. So just, yeah, come speak to me. Email me if you want the slides, just as a reminder of what we've covered. And yeah, thank you for coming here. I don't know if there are any questions. Yeah. Yep.
I understand all of this advertising with the Apple Ceph default. I mean, all
Sure.
that security
Yeah.
And I wanted to hear your perspective, especially working with the third-party integration.
Yeah.
That could be either really a truly third party or just internal. You're using another organization's software, like maybe you're working for a large corporation. So I'd like to have your perspective on that.
So here we're not talking about like what Sneak does about like packages, right? Sort of checking that that the packages that you're included in the libraries that you're including in your application are. We're not talking about stuff like what Sneak does. I'm talking more about integrations to, for example, Twilio or Stripe, where your application is expecting some and you're doing a validation to make sure that what's coming into your application is what's expected. But if you're not doing that step of sanitization and validation, then you are at risk of being breached through that that surface. Now. Yeah. I guess this is where we sort of have to, in some ways, hope that the organizations that we're depending on for services are also applying best practices when it comes to their APIs, that they're also enforcing an API contract that is very clear to you as a developer that's integrating with the service. And yeah, just don't implicitly trust that because it's a brand name, that they're doing things correctly. You should have the steps in place to make sure that what's coming into your infrastructure isn't going to affect it negatively.
That means you can't work with a mom and pop shop. It sounds like the other companies have to do whatever you expect, right? I mean, does that sound like now you have to really, any third-party software you work with has to be solid and all that. So, yeah, I understand that.
Yeah.
So good luck to mom and pop shop. You don't have all this stuff.
It's a funny one. This unsafe consumption of APIs. There's actually like a little bit of a debate right now in the OWASP community about whether actually this one should be included. And the main argument for its inclusion is the fact that there's less just awareness of this being a vulnerability versus just inputs from users. Inputs from users, definitely. I'm pretty sure every developer knows that there's many vulnerabilities that come through that. But inputs from third parties, not as much. It's part of the API economy, I guess, which is like a growing thing. Yeah. Well, I work for Firetail. I would say that's one. We have some open source components, which is why I'm sort of allowed to talk about it during this sort of during SCaLE 20X. So that's definitely one. I'll open the room if anybody has any other suggestions for. Okay.
It detects the smells code and, you know, you need to detect security things. So that's open source. What's the other one? There's Checkmark, no, Checkmark is out.
No, I'm not sure.
Well, that's the one.
There was another question in the back. Yeah.
One question is, you flipped from the last slide too quickly for me to get your email address.
Oh, okay. Yeah.
Okay, so it's just hold a second. The other thing I was going to bring up is outside inputs. I still love the hack in Vegas where the casino system got hacked from their fish tanks.
From their fish tanks.
The fish tanks, they put them on the same network as the other machines, and somebody was able to
I love that. I'm glad that we've moved on from all the violence from the Industrial Revolution. We can laugh about these sort of breaches that don't have any sort of, violence associated to it. Yeah, that's a great example. I love it.
They didn't give out a ton of details and they was thrilled about doing that type of thing, but supposedly they have these big expensive aquariums all over Vegas. And so they put in sensors to help monitor things like salt levels. And they basically wired them into the same network that their gambling was using. And so when somebody had, it's kind of like what happened at Target, where they had the HVAC system hooked into everything else. Yeah, it was
Yeah, segmentation definitely an important principle. So I don't know, was everybody in the room present when I started the presentation? Because I was considering sort of just redoing it, since this was like a 30-minute presentation. I have time to do it another time, but if everybody was already present, then I don't know if it was actually worth it. I can brush through it if you guys want. We have like a 20 minutes to go over it. Yeah, may as well. All right, so yeah, the subject of today's presentation are the top API security risks, the OWASP API top 10 in a nutshell. So a little bit about me. Graduated from the University of Montreal. I was born and raised in Montreal. Then worked for the 4th Intelligence Company, Canadian Forces Reserves units, and then moved on to sort of startups, digital innovation, worked in cloud security. And then I have some interesting hobbies as well, or at least I find them interesting. So before we actually get into the subject of API security, let's talk about what came before, the sort of threats that happens in the Industrial Revolution. So what we had back then were things like highwaymen or stagecoach bandits that would sort of accost you as you were traveling city to city and would unfortunately try to steal your stuff, or sometimes even worse. Beyond that, you also had high seas pirates. The U.S.'s first overseas conflict was actually with some Barbary Coast pirates in modern-day Libya. It was not a conflict that went particularly well for the U.S. at that time. This is a long time ago, early 1800s. And then, of course, nation-states had many, many world wars, more than just the two of the 20th century, even before that. But yeah, we're no longer just in the Industrial Revolution now. We've moved on to the digital revolution. So what sort of threats do we have nowadays? Well, you can get some physical attacks directly on a physical data infrastructure. So think an AWS data center, for example, can be attacked. You can have digital disruption to your operations. So think of the breach or the effects that happens during in 2021 on the Texas power grid, where a company that was managing the supply chain for oil suffered a ransomware attack, and essentially you had some very long lines at gas stations. You had some very high gas prices as well. Nothing good. Third, you can have some IP theft or actual asset theft. I think IP theft, that's generally understood. Someone steals your code base and then just understand what you've been working on. Asset theft, think, for example, NASA sending a satellite to space, and then the only control system for that satellite being taken over by some malicious group. Could be more than just satellites, could be drones, could be rovers, anything that's remotely controlled, essentially. And then finally, PII data exfiltration. So yeah, there's some real reputational and monetary loss that can happen off the back of PII data theft. So how did we actually get here? So we've established that today the threats to industry are different than what they were previously. They're consistently changing. So 5 or 6 years ago, I was helping organizations safely get migrated to the cloud. I saw all kinds of cloud infrastructure issues. So the issues are not the same as what happens today. Best practice changes, and today what we're seeing is that APIs are becoming much more of an important source of vulnerabilities to organizations running IT infrastructure. So this brings us to the subject of today's presentation, application programming interfaces, and the OWASP API Top 10. The release candidate of actually 13 February 2023, so very recent stuff, less than a month old, this version of the Top 10. So, number one, broken object level authorization. So if you weren't here the first time I gave this talk, the first two, this broken object level authorization and the next one, broken authentication, this represents the vast majority of breaches, so 70+% of breaches, according to our research at Firetail, looking at the past 10 years of publicly disclosed breaches. So for this one, broken object level authorization, devs will just often incorrectly assume that authentication equals authorization. That's not the case. They're going to assume that an API call will only be coming from known good client software, like a mobile app, and that's going to help them control the parameters of API requests, which will then make it impossible for user A to request user B's data. Unfortunately, that's not how reality works. Any sort of predictable pattern in an application's data structure can be exploited by a malicious user. So if you're not using random and unpredictable values to identify your data objects, then they can be protected and so are much easier to exploit. So let's use a rideshare app example. Say a malicious user guessed your rideshare account's user ID because they figured out that those IDs were sequential. For example, 101, 102, 103. That attacker could then mock a legitimate API call to fetch information about that user's ride history, the legitimate user's ride history. So that's a sensitive information, a PII data breach. So essentially, this unauthorized user gained access to a data object that they should not have had access to. So if the rideshare app's backend doesn't check that this user, this malicious user, is allowed to access the specific data object in question, then of course the API is vulnerable. So the mock request made by our malicious user, it's only going to go through if that mock API call is not properly checked for authorization. If the user making the mock request actually receives the ride history that they're requested, that's a breach. The authorization check was not made by the application logic, and object level authorization, of course, has been broken. So if I haven't been clear, this is really, really bad. This is the sort of security breach that security professionals lose their jobs over. User A getting user B's data is really, really terrible. It's worse than sort of marketing data breach where emails and first names get released. It's much worse than that. So yeah, it's a really good idea to use unique user identifiers or globally unique identifiers to mitigate this risk and ensure that all functions actually check for authorization. Number two, and again, these first two, by far the most important of this top 10 list. This one is about user impersonation. Can a malicious user trick your application into believing that they're someone else? So there's a few common ways that this can happen. Credential stuffing, that's one of them, that's using a pre-made list of usernames and password and trying every single one of them out until one of them works. Another one is using brute force attacks against a specific user, where an attacker tries out different passwords or MFA tokens until they find the right one and take over the account that they're looking to take over. Third, think of poor in-transit security, like lack of encryption or just poor or no hashing, putting auth tokens or passwords in your URL. This can make your users very vulnerable to attack. So malicious users are then able to intercept those authentication details by sniffing the network, and then this would lead to a man-in-the-middle attack. Fourth, tokens or other credentials that are properly generated by the front ends, but then never actually checked for validity by the back end. So your front end here is doing everything right. It's your back end that's not using what the front end is giving them and checking that the authentication is legitimate. And then finally, exploitation of deep links or other one-click authentication mechanisms that aren't properly secured. So to summarize, broken authentication is essentially a malicious actor gaining access to a real user's rideshare accounts and then ordering for themselves as many rides and as much food delivery as they can get away with. So some best practices to implement to limit your app's risk here. Use minimum password lengths, rate limits API calls, don't rely on long-lived credentials, and implement CAPTCHA or other "are you a human" tests to your authentication services. So an easy example of a breach here happens late last year, so not very long ago. Optus, this is an Australian telecommunications company. They were affected by a breach because a network configuration change exposed a previously 100% internal API. And this API, well, doesn't check for authentication. So security through obscurity, it's not good enough. Implement authentication everywhere. Yeah, again, these first two, by far the most important of the top 10. Moving on, so broken object level authorization. Again, let's use the rideshare example. Marketing team had a great idea. They want to show the world how diverse the rideshare app's user demographics are. So they're having the public website show a rotating feed of user first names and the city that they're from. So it's fine, right? It's nothing too crazy. They really only need the first names and the cities for the website. That's not personally identifiable information. Unfortunately, the backend service that they're using to power this, this new website feature gives them the full user object that returns it to the public website. Well, it's just easier to develop that way, right? It's easier to just get all the data and then cherry pick the few fields that you need to do to build your feature. Unfortunately, all the extra data is actually still there. It's just a few clicks away for someone with very basic technical knowledge. And unfortunately for our example rideshare company, the extra user data contains some pretty sensitive info, like a new field for bookmark addresses. And suddenly it's not just a fun new addition to the website, it's a user data breach. So what could have been done to prevent this? A couple things. You should handle data sanitization on the server side. Only return what's actually needed. You've heard the expression, need to know. Well, since the website doesn't need to know about user PII, just don't send it back. Cut it out before it gets included in your API response. And also, you should maintain an API contract, and you should make sure that it's being enforced. So the contract should have stated that user bookmarks are for very specific scenarios that don't include the public website. With this in place, that PII would not have been sent back to the public website. So fourth, unrestricted resource consumption. If your API is being hit by so many calls that your servers are made unavailable, you've probably done something wrong with the design of your API. It can lead to denial of service attacks, which make the news very frequently. Hacktivist collectives, they love this technique. It's very visible, can make a very big PR splash. Doesn't look very good for the organization suffering this. So if a request can make a call for an unlimited number of records from your database and your server actually tries to fulfill that request, it's going to affect the performance of the database and all the services that actually depends on that database. So furthermore, if a malicious user can send your server a 2 terabytes JPEG as their profile picture, and your server doesn't handle that gracefully, it's going to have an effect on the serviceability for other users. So this is where rate limiting, pagination, and a transparent API contract come in. So rate limiting, that's going to prevent users from sending requests at a rate that is too quick for your backend to handle. Pagination will also allow users to slow down their access to your databases by returning a different set of results with each request. So think items 1 through 99, items 100 through 199, and so on and so forth. So a clear API contract here will mean that users, including the team responsible for handling the client side, are aware of the limitations of your API, and at the very least, pagination and rate limiting will minimize the scale of a breach. So it's difficult to be completely safe from denial of service attacks, even more so distributed denial of service attacks. Hackers can very easily change their IPs, change their device IDs, And yeah, it just makes it very difficult for you to differentiate between what's a legitimate request and what's a fake one. So for now, suffice to say, the more visibility that you have on incoming requests, the more it will be possible for you to catch the ones that are intending you harm. Fifth, each API call that's being made to a server is received and processed by a specific function in the application. So before executing the code, the functions that evaluate the metadata that was passed along with the API request, this data is going to include things like who made the request, what type of request was made, and where the request should go. So a user, let's go back to the rideshare example, very easy one. A user who requests a ride should be the only one that should be able to interact with the function that handles payment processing for their accounts. The driver who gives them a ride, that's a different user in the application, should not have the ability to mock the user API call to the same payment processing function and change how much they're being paid for the fare. You can very easily see how this would be beneficial for the driver, but not very good for the person paying for the ride and for the organization managing the application. If you're not using the principle of least privilege here to define a limited scope of user-allowed actions, then you'll be vulnerable to broken function level authorization. So to avoid this, you should use very granular access control to define who is allowed to do what in your application. So as a rider, I can modify how much I leave as a tip for a ride that I've taken. As a driver, I can view how much was left for me as a tip for a ride that I've given. So unfortunately, it's like a lot easier to write an application that treats all users the same without making the distinction between modify or view. Yeah. Sixth, server-side request forgery. So this is where, this is actually a new one to 2023. This is where the vulnerability allows attackers lateral movements from a public-facing server to internal-only resources. So this can lead to data exfiltration if the server can be forced to interact with third-party resources. So you should make sure that your network topography, meaning how you've set up your network architecture, you should make sure that it doesn't let the servers that you use to fetch external resources then also interact with internal-only resources. So be very explicit about what sort of URL structures and which ports should be used by external services. And if you can, it's a really good idea to use a whitelist or a list of allowed IP addresses or DNSs. So as always, validate and sanitize all input data before it reaches your data layer, but also checks outputs before they're sent back to clients. So this one, security misconfiguration, that's a rather large category, right? It'll include things that pertain directly to the API and its infrastructure, but also things that are higher up in the application tech stack, but also further down in the infrastructure stack. So these misconfigurations are often going to be part of vulnerability chains, where essentially the idea is to link together multiple exploits in a row to gain access to like a better exploit of the infrastructure. So for organizations that maintain APIs, like just one vulnerability probably won't cause a catastrophic breach. But usually if a security researcher or hacker finds one, they're probably going to find more than one. And if they can chain more than one together, then that can lead to a much higher impact breach. So in a rideshare example, let's give a simple two-step vulnerability chain example that allows for account takeovers. So the first vulnerability in this chain will be that in the login process, specifically logins through Facebook, a faulty implementation of the login mechanism means that the rideshare app's auth step can be injected with the Facebook ID of an account controlled by an attacker. So this Facebook ID would replace the ID of the legitimate user. So this would allow the attacker to bypass the Facebook login step. So the next step would be passing the multi-factor authentication step. So here, unfortunately, in our app example, rate limiting was never actually implemented on this endpoints, checking for the 2FA code, meaning that the attacker can use a script to try every single possible combination of the 6-digit verification code. And yeah, that allows them to pass through the MFA step. And so those two vulnerabilities sequentially leads to a full account takeover. Each one individually, probably fine. You won't actually gain access to anything, but both together lead to bad things. So let's go back specifically in what terms of misconfigurations can happen. So insecure transport protocols, TLS version 1.3 is the latest. It was released in 2018. It's the one that you should use. Use HTTP methods. You should only allow the use of HTTP methods that are necessary for your application. There's a lot more than you think. Just don't allow them for your endpoints. Third, require the latest HTTP security headers. So HSTS, content security policy, X-frame options. These are HTTP security headers that are good to use nowadays. These are still best practice. Fourth, overly descriptive error messages. So Windows is notorious for this. So to give an example of a breach that was caused by this Starbucks.net server, it was an important link in a vulnerability chain that led to a PII breach that was reported by a security researcher. Fortunately, not by an actual hacker, but still a bad breach for Starbucks here. So yeah, make sure that your endpoints return error messages that don't expose anything about your application's logic. Be very generic, short, still give some information about what can be done to fix the request that was sent to your endpoint, but don't expose anything about the underlying logic. Fifth, use HTTPS. I know, very basic stuff, but still we see APIs not enforce the use of HTTPS, so yeah, good to use. And sixth, enforce a cross-origin resource sharing policy, a CORS policy, that restricts data flows to only pages or domains which should communicate to each other. And then finally, everything related to your infrastructure misconfigurations, just follow the security pillar of the well-architected framework. That'll go a long way in making sure that the infrastructure powering your APIs is not going to be what leads you to a faulty or vulnerable API. Eighth, so lack of protection from automated threats. Also a new one to 2023. So Ticketmaster was famously recently affected by this during the sale of Taylor Swift concert tickets. Malicious users were able to exploit the APIs from Ticketmaster to get every single ticket for the Taylor Swift concerts at what turned out to be very cheap rates compared to what they were then able to sell them for. So it was all over the press. It was called a fiasco. There was a Senate investigation. It was a whole thing. You guys have also all been affected by sort of spam comments on LinkedIn, Facebook, Instagram. Yeah, these happen all the time. The point here of those examples is that attackers are going to use very normal user flows within your application, but they're going to do it in an exploitative manner, which makes the experience worse for everybody else. So our lab at Firetel, we've shown that actually 90% of requests to APIs will be bots that are going to be scraping for secrets. So things like .env files, git.config, graph query, or admin endpoints. Yeah, bots are going to be looking for those to exploit it. So to mitigate this sort of thing, OWASP recommends using mechanisms like device fingerprinting or user flow analysis to identify and block automated threats. So sometimes when I'm Googling stuff at a frantic pace, I get redirected to a CAPTCHA before I can reach my results. That's the sort of mitigation strategy that isn't too obtrusive to normal users, but would most likely vastly reduce the impact of automated threats. 9, improper assets management. So APIs routinely use versioning to account for the sometimes conflicting priorities between development velocity and support for legacy systems. So despite releasing a version 2 of your API, you may want to give a grace period to the legacy users of your API. using version 1 so that they have time to update how their applications work with your latest version. So in theory, this would be fine. However, in practice, and given real-life time constraints, development teams will make the decision to just implement the latest security best practices on the latest version of the API and just forget about updating the previous version. So you should at least be aware of what you're running in terms of APIs, what's online. You know, if you have zombie APIs in your stack, at least be aware that they're there. You shouldn't be running them at all, but if you are, well, you know, it's good to have visibility. And then to make this even more professional, you should maintain an API hosts inventory. So what's an API hosts inventory? Well, it's different to an API contract. The contract is much more at a tactical level. It's defined by documentation, often created through Open API spec, and it describes how you can interact with a specific application or service. The hosts inventory will encompass all of the API contracts. It's much more at a strategic level, and yeah, will enable security teams to sort of have a better visibility over their scope of responsibility. So properly managing new releases also falls under the scope of this category. You should always set up distinct environments for dev, test, staging, production. Don't use prod data in pre-prod environments to test. Not only are you creating a risk for potential data breaches, but also it exposes your internal teams to sensitive customer data. And that in and of itself might be a breach of GDPR or other local regulations. So how to mitigate this? It's usually through operational controls. I mentioned the API hosts inventory, but you should also categorize your public APIs and make them different to what APIs that are meant for internal or private use. So ensure that your APIs can interact with the APIs that can interact with personally identifiable information are tagged as such, so at least you can take a better look at them than the rest of your stack. So as long as you maintain a really good understanding of the data flows and the connection between the services in your stack, there's a better chance that you'll be able to, be one step ahead of attackers. So last one, I know we're going a little bit over time. This is our second run through. Thank you for being here for both. And again, it's new to 2023. So we're clear that user inputs into your application are vulnerable to exploitation. But what about third-party service inputs? So unfortunately, devs tend to trust, and understandably so, other companies' APIs more than they trust their own users' inputs into their applications. So the conclusion of that is that the devs are more likely to adopt weaker security standards for input validation and sanitation when it comes to those third-party service inputs. So there's a lot of different exploits that can be achieved through this vulnerability. Think data exfiltration, remote code execution, denial of service, and all of this can be done through a compromised integration to a third-party API. So the message here, to be clear, you should apply the zero trust security model to integrations as much as you do for user inputs. Treat them the same. It's not because it comes from a trustworthy company that's what's going to happen is meant to be trusted. So to give an example here, imagine what would happen if Twilio or Stripe, very commonly used services, were breached. And then all the downstream integrations to their APIs were exploited through that breach. Not a good situation for anyone involved in those scenarios. So my call to action today, well, first, thank you for coming. We're looking to partner with organizations that are building APIs and on AWS, ideally, and we just essentially want to learn about their problems, concerns, their complaints, what their life's about. And at Firetail, we've built some open source API security libraries that we'd love to share with you, love to get your feedback on. So just come speak to me. If you want the slides, just email me and I'll be happy to send them to you. So that was it. Thank you. Any questions? I'll take that to mean that everything was clear. So yeah, thank you for coming. Think of T-Mobile, how many times T-Mobile has been breached in the past few years, and how much they've invested in the protection. They've put in hundreds of millions in trying to secure their stack. They keep getting breached, and oftentimes it's APIs. Now, unfortunately, there is a challenge behind doing security research on like publicly disclosed breaches, in that they don't want to be too revealing about how the breach happened because they don't want to inspire copycats. But yeah, it's a very growing source of vulnerabilities and breaches, API and that. It's if you're at all aware of what was happening with S3 buckets, for example.
Sure.
Yeah. Yeah, that was like super obvious stuff that was happening like 5-6 years ago.
Just within the next 3 months, it's going to lock it.
Right. So like Amazon put a ton of effort, and all the other cloud providers put a ton of effort into making sure that that their data storage services were secure and very easy to secure. APIs, unfortunately, there's no major vendor behind this, right? Everybody does it differently. Yeah. So, but like the conclusion, if you keep in mind that you're doing authentication and authorization properly, you're covering 80% of the source of breaches.
Every device on their network has a default password. And it's only been in the last 2 years that like Sony, Samsung, the big ones, have forced when you deploy their equipment that you have to change the password.
Right.
I mean, I have a tool called a cam radar for tracking security cameras. Say 5 years ago, I had a database that's admin, manager, 3 others, and a list full of passwords. I could break into almost anything because every vendor just deploys their defaults.
And oftentimes it's just lack of awareness, right? They just don't know that this feature is there. They left it.
No, it's not lack of awareness. It's ease. Because if I go in there and change it, put a complex password, and then a month later, the customer needs to make a change. No matter how many times I've given them that password, they can't remember it, they lost it, whatever. And if I use a unique random password to a customer, I can't go back in unless I'm using it. Well, I don't want to be using your passwords. So no, it's not lack of awareness. It's just as VARs, we're not going to put strong passwords on unless you force us to put strong passwords.
Basically, they haven't been asked to do it, so they don't do it.
And no customer's ever asked me to put strong passwords.
Keeps you employed, right?
Customers have no centralized password management system, and if you put a complex password on and this guy clicks, well, I don't want to mention the name, but I'm doing a large city right now here in California, and they have 300 cameras protecting critical infrastructure.
Right.
They have no idea what the credentials are.
So
Yeah.
can they not
And they
use
don't
them?
want me to attack them because they're ancient and they'll fall under it.
Right. Yeah, growing problem.
I'm Krobe. I'm the Director of Security.
Oh. Yep. Yep.
Hi, everyone. Great.
Hi, everyone. How do you trust open source software? I'm Naveen Srinivasan. It's just a little bit about me. I'm happy to be here to talk at SCaLE this year. I am all about supply chain security and open source software. I'm a maintainer and a contributor for a few projects in OpenSSF. I'm a member and a contributor to Zeek store, and I'm a contributor to Salsa codebase. All these three are GitHub organizations focusing on supply chain security. And I've been actively contributing open source for a few years, which helped me get Google Peer Bonus Award in 2021 and 2022. Right now, I'm an independent developer looking for ways to contribute onto new projects. And if you want to check out my profile, if you can check out my GitHub profile to see what I'm doing. And if you want to talk to me anything about supply chain security, open source software, you can hit me up in Twitter.
Great. So welcome, everyone. My name's Brian Russell. I'm a product manager on Google's open source security team. I work a lot with the OpenSSF, and I, in particular, work a lot with OpenSSF scorecards. So before we really get into what the scorecard is, let's talk about the problem that we're facing. So we've got this blocky looking diagram here, and we can think of it as basically what modern digital infrastructure looks like. Oftentimes when you pull back the cover and take a look at what's running underneath any system, you've got a whole bunch of different pieces there. They come in different shapes and sizes. And some of them are very important. Some of them are more precarious than others. But what you have is a real mix of different things. And you don't have a lot of insight into what's actually going on in terms of making these blocks in the first place. You might know how important they are to your system, but understanding how they're developed, how that community operates, that part is usually pretty opaque to a lot of people. So that begs the question, what if we did have some insight into what's going on in this infrastructure? And that's really what scorecards is wanting to help start being able to help people see. So if you have these scores, you have all of a sudden a sense of which projects are doing really well in terms of embracing best practices in developing software securely, which projects could use a little bit of help, could be doing a little bit better, and then which projects are actually doing really quite bad. They don't really think about security when they're developing, and those are the projects that you would want to concentrate on if you're using them or if you're bringing them into your own open source project as a dependency. It's important to direct your attention kind of where it's needed most. So here's what a scorecard looks like. There are a few ways to generate it, to pull this data. This is coming from a service that, shameless plug from the Google side. It's made by this site called deps.dev. It lets you go in and see for any open source dependency, what do those dependency trees look like. It also provides scorecards though, and it's a nice UI experience if you're just wanting to look up a scorecard for a particular project. We'll get into a little bit more how those scores are generated and how we would source them, but in a nutshell, the scorecard project right now is running effectively a cron job that every week is scanning the top 1.5 million projects as computed by a sort of criticality score, how important they are in the rest of open source. So feel free to follow along on this next part. If you want to take a look at a scorecard, you can pull it up on your phone. You can either use a QR code or just go to deps.dev, and you can think about a project that you already know about, or maybe one that you're helping to maintain. Any project that is within kind of that top 1.5 million should have a scorecard associated with it. If you just want to find a project, you can always just look up scorecard directly. You should see a sequence of screens, something like this. I'll say it's always a little bit better on the laptop, but I made the screenshots with a phone in mind. So if you go type in scorecard, look for the specific little project folder that's associated with it, you can scroll down the page a little bit and you can start to see a scorecard. So we're back to this list of checks, and now let's talk a little bit about what these actually are. So in a nutshell, we are looking for what are generally considered best practices when it comes to developing and managing a project securely. And each check is composed of a name that you're seeing here, a score, and then some underlying logic that goes out and actually looks for evidence to compute that score. So I'll go into a few just checks. I thought about going through the whole list, but it seemed like let's start with the top 5 and just kind of go from there. So if we look at our first check that's on the list, we've got code review. And in this case, it's looking for, does this project require that someone else reviews code before it's merged in? And each check is composed of a risk level as well. And so they range from critical to high, medium, down to low. And in this code review sense, there's some caveats here. We certainly recognize that there are single maintainer projects where code review is not going to be feasible, but it's basically one kind of piece of evidence and one component of whether or not your project is basically building a community that's looking at things together, if it's looking to develop things securely. So I'll go through 4 or so other ones just to give you an idea of what each is. I should mention too that for each of these checks, the way that Scorecard works, it's calling the GitHub API right now. We're working to expand that past GitHub to some other places, but these aren't kind of self-certified pieces of evidence. All of this is just gathered programmatically, checking for things that you could check just as a general user coming to GitHub. So if we just go to the next check down, we look at maintenance. Is this project still actively under development? For pretty much any project that is in active development, there's going to be some activity that happens on it. So we look across a 90-day window, whether or not things are being done, if updates are being made. We would expect to, if dependencies need to be updated within a project, all of those things should be happening, and so we consider maintenance one of these checks that Scorecard's looking at. If we jump a little bit down, we want to make sure that just permissions to actually change the repo are configured in a way that it's read-only. Each of these checks has specific descriptions of how they're implemented, so you can see whether or not they would pass. But when it comes to token permissions, we're really just looking at who has access and whether or not they have more access than really they should. We also look for dangerous workflows. There's different patterns such that, if you have your project configured in a way, let's say that it kicks off some CI when a pull request is opened, and someone can basically insert their own sort of script to run that, that would be considered a dangerous workflow. So there's a few different patterns that we're looking for when we run this particular check. And then the last one that I'll just highlight here is binary artifacts. This plays very much in open source mentality where we want there to always be the actual source code and not some compiled code that we can't understand. So there's a few exceptions where different specific frameworks require binaries as part of how they develop software, but we're looking for anything past those, and we're trying to make sure that overall you are just storing source code in the repo itself. So different questions kind of come up. We're trying to get better over time of kind of explaining, can I use scorecards if you have a private repo? The answer is yes, you can use scorecards on that. You can run a CLI tool against your repo. You can set it up in a GitHub action, but you can run this privately. It doesn't have to be a public repo. let's say that you use Git, but you do not use GitHub. The answer is yes, but there's some limitations, specifically anything that's tied to the GitHub API. That would require the project to be on GitHub, but we can check for a number of things that are independent of where you store your Git repo. And then if you're using GitLab, the answer is soon. This is something that is currently under development and something that we're planning to be pulling in the next few, let's say, months at this point. So that's generally what a scorecard looks like. That's how checks work. We've seen a few different examples of what checks are. Sorry, you have a question? So you're saying in terms of like for deps.dev? We'll get to that, but the short answer is you can install the GitHub Actions action. That will automatically score the project, and it will automatically push that score to deps.dev. It's a good question. We also have a few minutes purposefully left at the end of the presentation, so if you have more questions, we'll definitely have time to talk about them further. So I wanted to talk about here just what is this general state of supply chain security that we're in right now? Like, exactly why are we talking about scorecards? What is kind of the bigger landscape that this is operating in? Well, to start with, open source software demand is always increasing. The Linux Foundation published in a blog post that free and open source software constitutes something like 70 to 90% of modern software solutions. And on top of that, just the downloads of open source dependencies has been growing by an estimated average of 33% across all of the ecosystems that they were looking at. So we know that the demand is going to increase. What we've also seen, and this is from Sonatype's State of Software Supply Chain report, which is free, and I highly recommend people take a look at if it's not on your radar now. They looked at specifically what is happening with software supply chain attacks. And they found that, this graph really tells the tale all by itself. They're increasing a lot. More and more, people are trying to find ways into any sort of system, and often dependencies that are being pulled into the system and used there are suddenly becoming one of the easier attack vectors to hit. I think in part because some of the other good security best practices are getting followed more and more, but that means the software supply chain suddenly becomes one of the more vulnerable pieces. So what's this have to do with scorecards? Also in this Sonatype report, there is a specific section in which they started to look at what can you look at to really see if a project is likely to have vulnerabilities over time? Like, is there any sort of indicator that we can use to really see, if this project has these certain things in place, are they less likely to be vulnerable? And what they found was that scorecards could be at least a decent predictor of whether or not vulnerabilities would show up. Over time, vulnerabilities are reported at different times, but a higher scorecard project, a project with a higher score, usually indicated that there was a lower probability of vulnerabilities actually being found. And then in this report, they also broke down which checks are more important than others. You see that code review is actually the highest one, which intuitively makes sense. If you have more people looking at code, you have less likely of kind of making a mistake. Scorecards has had adoption and some notable mentions by various foundations. I won't get into each one. I'll highlight Eclipse just though off the bat. Like Eclipse is basically using scorecards to take a look at projects within their foundation, using it as really a good starting point of where they can invest in different software supply chain improvements. And I think their example is good for a lot of organizations where, if this is a problem that you're starting to be concerned about, like this is a good foothold to get you checking for some basic things to really see if some of the very basic pieces are covered. So rather than kind of give more examples, we asked one of our scorecard friends, Christopher Robinson, or Krobe as he sometimes goes by. He's a director of security communications at Intel. We said, you know, what do you think about scorecards? And he sent us back this video that we thought we'd play for you.
I'm Krobe. I'm the Director of Security Communications at Intel. I'm also a community leader and contributor to the OpenSSF. I'm here today to talk about how my organization uses open source software and the OpenSSF scorecard. Intel has been a long-time contributor to the upstream open source community with over 20 years of involvement in a multitude of projects. We're also one of the founding members of the OpenSSF. We're extremely excited to see projects like the OpenSSF scorecard come into being because it not only helps us understand the security details about the open source software that we leverage in many of our products, but also internally. And it also helps us understand the security qualities of our own products. Right now, Intel's making sure that all of our public GitHub repos are reporting out through the scorecard tool so that we can understand where we can improve, but also so consumers of our software understand the types of things we're doing. I think Scorecard is an amazing project that has a ton of value to help describe the security posture of open source projects up and down throughout the ecosystem. So I can't endorse it strongly enough if someone's considering a way to evaluate open source software. The Scorecard is an excellent way to make that happen. Thank you.
All right, and thanks to Krobe for sending that to us. So if we, before I hand this off to Naveen to do some demos and explain a few more things, I did just want to say a note about what the OpenSSF really is. I used it, you know, just in the actual name of scorecards, but we wanted to talk about what this foundation is really seeking to do. It was formed around 3 years ago at this point, and it really is meant to be a place where different organizations who are very interested in trying to make open source software more secure for not just them, but the whole world. It's a place for them to come together, to have conversations about how can you actually do that, a place to really invest in different tooling and to just really try to keep raising the bar on making software more secure. So it was formed by a few different organizations, but that number continues to grow. And I thought I'd say a note too on just, you know, how it works kind of under the hood. If you look at this top diagram, you can see this is the rough life cycle of source to production to the end consumer. And the OpenSSF has divided up different working groups along this different process. So they have things like best practice working groups where they're trying to just say at each part of the process what is going to help make things more secure. They have working groups around vulnerability disclosures and doing that in the right way and in a way that, you know, basically minimizes the vulnerability impact. Different groups around tooling, just other related projects in general. All of these things, if these are of interest to you, there's a lot of ways to learn more about the OpenSSF. There are email lists, Slack groups, there are public meetings, there are recordings of those public meetings that you can go back and view. They're active on social media, you can follow them, message them, you can use email directly. They actually have a page where all of these different things are consolidated, so it's just openssf.org/get-involved, and all of those links are right there. So that is kind of the intro so far to the problem that we're working on and the organization that we're working within. So I'll hand this over to Naveen to talk a little bit more about how else you can use the scorecard.
Thanks, Brian. Like Brian mentioned, one of the ways, there are multiple ways to utilize scorecard. You can use scorecards CLI, GitHub Action, but last fall, and this has been there for, the CLI has been out for almost a year and a half too, and last fall, we released a scorecards API. Why did we release an API? Because we spoke to customers, and and because we've been scanning this 1.2 million repositories, which I'll get into, all of this data is available for anyone to consume using BigQuery. And it's been doing, the cron job has been running every week, and it's been doing it for the past 1 year, so there's phenomenal amount of data available. But the biggest problem we realized is people like to use HTTP API, standard simple get API to go get this data. So that's why we exposed the scorecards API. That was a specific reason behind this. Where is the API available? The API is available api.securityscorecards.dev, and we made sure that the API is predictable. What I mean is, you can see here the simple example of hitting Kubernetes. It's a simple curl command. It results in a JSON output. It's got get and post. Right now I'm going to focus on get, but I'll tell you where the post is going to be utilized. We also made sure there are no security tokens, authentication required for this API. So anybody should be able to utilize this API. This is a free, maintained by the scorecards team. At this moment, we don't throttle the API. So please don't DDoS this. Like I mentioned, this is serving 1.2 million GitHub repositories, scans, weekly scans. There was at least one star to that is, for the past 3 months, we were rebuilding the infrastructure for that. We couldn't run, but you already have some of the previous data, but we have re-enabled, so you should be soon seeing all these scans running. Just an FYI, we have been seeing about 150K requests per day, people using this API. Who is using this API? We don't know. It's a free API. Sometimes we get GitHub issues wherein people come and ask for API rate limits. But if you're using this API, if you're interested, please come and talk to us. We are more than happy to understand what people's needs are. One of the things that Brian mentioned was code review. So we said, and there's another sister project within OpenSSF called Criticality Score. What Criticality Score does is it takes a million repositories and figures out which are the most critical, and it uses an algorithm by Rob Pike, and it uses that to figure out the top. We used the data to figure out the top 1,000 critical projects and wanted to figure out what are the state of code review, because we realized code review is a critical thing, and we used the API along with this data, and we were able to graph this. Why am I showing this? So anybody within your projects, within your organization, you should be able to utilize something similar and figure out what is the state of any of the projects that you depend on or you build. Looks like most of them are doing well. Some of them need some help. Okay, enough talk. Let's go to code. So what I'm doing right now over here is I'm going to hit the scorecards API, but I'm going to hit the scorecards API for scorecard. I'm piping it to JQ, which is, because it comes out of JSON. One of the checks that Brian mentioned is maintained. Here is simple as, looks like scorecards repository maintain a 10. It's between 1 and 10. We are doing well on that. And let's go back and check another check. For example, token permission. That's one of the critical checks, and gives out results like this as a JSON. So you should be able to parse this and programmatically use this. Looks like scorecard repository itself needs to fix one of this. That's why we ourselves have score as 9. Let me go back to the slide. And if you are interested in you building the, I open source the project for building the 1,000 critical projects, and that's in my personal repository. You should be able to pull down that repository and go ahead and build anything similar to this. It's written in Go. But you should be able to use any modern programming language to build that. Let's talk about the usefulness. We're going to play I am a contributor.
And I'm a project maintainer, and I care a lot about security.
Brian, I want to submit a PR with a new dependency.
So thank you. That sounds really good. But can you tell me about this dependency? Is it in a healthy state?
Would a scorecard be helpful, Brian?
I'm not really sure what that is. What is a scorecard?
Have you checked out the scorecards repo, Brian?
Okay, so I hadn't, but this is great. And in fact, I think I'm going to be using this API to be checking on all my future dependencies. In fact, I think I might use it in my CI/CD tool as well. And it's also just so easy to use. Now I'm starting to wonder, just why doesn't everybody use Scorecard at this point?
Thanks, Brian. We realized what we did, and the scorecards team thought about what the API was, and we are building a feature to specifically address this. It's still not merged in. So what this specifically does is, anytime a new dependency comes into your repository, it figures out what is the new dependency and gives you a GitHub comment on the health of the dependency. So it's almost like running scorecard anytime a new dependency is added to your repository. This is something we're working on. It's still not merged in, but just wanted to give a heads up of what it is right now. So you should be able to see a comment saying, hey, this is the dependency, this is when the scorecard ran for this, and here are the scores that you can see. So it helps you make some decisions as to what you want to do with the new dependency, whether you want to accept or whatever you want to do with that. The next thing then the scorecards API was, there's another thing that we released last year was scorecard badges. The badge is very similar to what it is. It shows what is the score of your own, of anybody's repository. So essentially it helps humans understand whether it's how safe that project is. So that's the idea behind the badge. The badge in turn uses the GitHub action. You need to have the GitHub action to get the scorecard badge. And this is where the GitHub action uses the API for posting data. Thanks to Brian, we don't want to go install the action manually. Brian recorded this for us. So here's an example of a repository. Now we go into scorecards repo. There's a specific section how to add a badge. And we are copying that, going back to the original repository, going to the README section, pasting that specific content, just replacing it with the owner and the repository. It's as simple as that. If we do that, we should be able to get a badge for the repository. A caveat in this is, if you install the GitHub action, you get it, and if it's part of the 1.2 million repositories that we scan. If it's not in the 1.2 million repositories, you have to install the GitHub action to get the data. Another advantage of using the action is you don't have to wait for scans to update your scores. If you install the action, the scores get updated automatically anytime the commit goes into your main or your master branch. If I have only 30 seconds, what can I do? I can go to deps.dev, get some scores. If you have 5 minutes, you can run a scorecards CLI, get some data out of it. If you have 15 minutes, install a GitHub action, should be able to get the score out to the API, you should be able to utilize that. If you have more than a day, you should be able to utilize the API and bring it to your workflow. We want to make sure that anybody should be able to get some data out of this. That's our specific goal behind this. If you want to get involved, you should be able to hit up the QR code. We have a bi-weekly meeting. We meet every Thursday, every bi-weekly between 1 and 2 p.m. Pacific. And that's Scorecard's website. And the bottom are Brian and mine Twitter handles. You should be able to hit us up if you have any questions. Thank you. Any questions? Yes. Good question.
Do we want to, I think we want to repeat it so that it gets on the reel.
Okay. The question is, how is this project related to SIG-Store and SBOM? SIG-Store is part of OpenSSF. It's under the OpenSSF umbrella. And just an FYI, Scorecard's GitHub action uses SIG-Store to make sure that the action ran. It stores the data into SIG-Store store, so they are related. But Scorecard is not specifically generating SBOMs or anything on that. To be specific, of whether are we generating any SBOM, we are not doing any SBOM generation. Did I answer your question?
I just want to add, I think more generally, they're all trying to tackle different pieces of software supply chain security. And so, you know, the OpenSSF makes sense as this organization above where these projects are fitting. But if you think about like SBOM, it's trying to tell us this software bill of materials, what is actually in this project. And, you know, once you have that, you could pair it with things like Scorecard to get a better sense of what these dependencies look like past just knowing they exist. And when it comes to SIG-Store, being able to actually associate source code with a binary, like SIG-Store helps make that signature happen so that those connections are made. And so, again, if you're running Scorecard, you're running it against the project, but when you actually get a binary, you can say, oh, well, that actually came from this project. So each project has kind of a niche within trying to make the software supply chain more secure. But, you know, are both connected and disconnected, kind of depending on what the conversation is.
Yes. Good question. We have a...
Maybe repeat the question.
Sorry, I apologize. The question is to know the history of the score of a particular project, right? Just to make sure. So you want to go back in 6 months or few months to figure out what is the score of a particular project so we can see whether the project is doing well or not. Yes, Scorecard, like we mentioned, Scorecard runs for those 1.2 million GitHub repositories as a cron job. It stores the data in a BigQuery, and that is available for anybody to go query. So it's available free for anybody to go query the data. So you should be able to get a history for any particular projects.
Yeah, short answer, yes.
Go ahead.
So if the scorecard source was used as like a health and safety indicator, and the entire verification process is automated, what prevents the developer from scanning the system? Like just by making a cron job that connects every day and automatically approving any pull requests or things like that.
Do you want to repeat, or I can take a step?
Go ahead, Dave.
Yeah, so I think if I heard the question correctly, it's because this is an automated process, what's preventing a developer from gaming some of these checks? Like a developer just making constant, you know, minor changes just so it shows that it's maintained or it's active. So, you know, I think the short answer is there's no safeguard in place for it. We'd love to get to the place where scorecards are so dependent upon that people are making modifications, you know, just to try to boost their score. I don't think we're there yet. I think as that happens over time, we'll have to be looking at safeguards to try to limit that kind of behavior. I think, you know, the biggest thing is there are there's kind of two groups of checks in this situation. There's some that you could game, like the maintenance check. There's others where you have permissions set, and that one would be much harder to game. And so I think there's also the question of, you know, what is the motivation behind trying to game it? If it's trying to boost your project, if you care about making sure that it stays in a good security place and that you want it adopted, my hope is that people would also say, you know, I actually just want to invest in making sure I'm doing the right things in the first place. But, you know, it could happen. I think this is still a relatively new project too. We're still crossing those bridges as they come along. Great question. Yes? Yeah, so the question is anyone that's looking at different kinds of compliance talking with the scorecards project to see how those would work together? You know, I think I would say we haven't kind of dedicated a lot of time to trying to specifically plug in, but that is something that we're definitely interested in. I think in general, standards are still emerging when it comes to software supply chain security, and so we're trying to be part of those conversations, and we're working, it's part of why we're working, you know, with the OpenSSF and working to kind of make sure that we're consistent in how we act across these different projects that are within the OpenSSF. I will say if there's anyone here that specifically thinks a lot about compliance and would be interested in talking about this, I would love to talk with you after this talk and see if there's not a way for us to get plugged in more. But right now, you know, we're more at these are best practices level, and from that standpoint, you know, there's not a lot of back and forth debate on it, but we have a long ways to go with actually plugging into any sort of existing compliance. Yep.
I had a question about how, maybe about the engineering behind the dependency enumeration, and one thing that came to mind was, if you guys are good enough at doing that, wouldn't that be software bill of materials? Or you guys having that? Curious.
We use GitHub API to figure out the question is, do we understand the dependency tree, and do we understand what are the dependency changes? So we should be able to generate the SBOM. We don't figure out we haven't written code to figure out the dependency differences. We utilize a GitHub API, which gives us the new dependency changes, and we use that to go get the scorecards score for that particular dependency, so that we can get the results for that particular newly added dependency. Did I answer your question specifically?
Yeah, just so I understand this correctly, if a project has a dependency that is also a GitHub project, you guys can recursively grab that scorecard for that
So,
dependency, and that's how you guys build out your dependency.
okay. Not like that. So what happens is, anytime a new PR comes into the GitHub repository, what we do is we ask, and the GitHub API asks to, is there a new dependency added in this PR? The moment that we get that result, we go hit the scorecards API and get results for those new dependencies and populate in the GitHub comment. And that's how we know, that's how we are able to bring up those details up in as a comment.
And I want to make, I think, one kind of limitation of what we do clear as it is right now, which is, you know, you're right saying we're not recursively going through, because we're not, and you know, that is something that, you know, I don't exactly know for sure if we would make a hard call of whether that will be something we would ever do or not do. But because all of the metrics or all of the checks are at the project level, you know, we basically leave that as an exercise up to whoever wants to consume the scorecard to go out look at their dependencies, get the additional scores for them. We don't have the concept of like a super scorecard,
Yes.
you know, where, you know, your scorecard for a project is, you know, some combination of the best and the worst scores of its dependencies. That part's not there yet.
And obviously, and that's why we built the API so that you can utilize other tools to go get that dependency tree and utilize the API to get the score for that. You're welcome. Any other questions?
All right, going once, going twice. Thank you all for coming.
Thank you.